Well, good morning, everyone. It looks like we still have people coming in at the moment. Apologies for the couple of minute late start. All right. Well, my name is Ebony Roan. I am ADQ's OPSERT program coordinator in the drinking water section. We today are coming together to talk about best management practices for operators and indirect responsible charges. We've got quite a bit of information to get to all of you today. So without further ado, we're just going to go into a bit of housekeeping rules for GoToWebinar. Here. So in case you're wondering, today's webinar is eligible for PDHs. All the handouts, including the agenda you upload to your portal, all the presentations, including the agenda that you upload to your portal, are in the handout section of your GoToWebinar hotbar. I've understood that some people in the past do not have this handout section, so if you do not have that, please email the AZ OPSERT at the end of the webinar, and we'll be able to verify your attendance and send you an agenda. The webcams and all attendees, the webcams are disabled and all attendees are muted. So if you have any questions or anything you need to communicate, please use the questions bar or the chat bar. That is also on your GoToWebinar hotbar. This webinar is being recorded for viewing purposes. We'll talk a bit more about into updates of the website, but we now have a PDH log where you can track recorded ADQ webinars for PDHs. So that's the purpose of recording our webinar today. And that is the AZ OPSERT email and phone number if you need to contact us for any questions. Okay. Onto the agenda today. Like I said, we do have a full 4 hours for you today. I'm going to go ahead and start it off with a bit of a common alignment and program updates. I'm going to pass it off to Jason Bobko, the unit manager for the OPSERT program. He's going to speak on operational considerations for treatment plants. And then we're going to move on to required record keeping and retention tools for public water systems, electrical basics, bit of safety talk, and this as well. It is wildfire season, so Bailey will be assisting all of you on how to keep your system safe during this really hot, bizarre season. And then we'll finish it off with understanding construction drawings, more specifically as-built for systems. Okay, I'll go ahead and start this off with a bit of update on the common alignment. If any of you have access to your portal in the last week, you may have noticed a few changes, but you'll definitely see more of those changes when you're adding new certifications or updates. Hop into that. Common alignment it's kind of been a stickler, a very important point for certification management for operators. So I'll be covering what common alignment is in case you're not certified or you haven't had to use this feature because you maybe only have one certification, you have no intention of adding another. I will be going over the new process for common alignment. Pretty similar, just more options. And then I'll be discussing whether you should align or should not align. And then I didn't add it here, but then I'll put up a few more updates for OPSERT coming up in the next month, within the next month. So what is common alignment? Common alignment, specifically for Arizona, is a certification management feature that allows new certification expiration dates to take existing certification expiration dates. So when you add a new certification, it'll say, do you want to align expiration dates? What they mean is if you have existing certs, say you have a T1, you just got a D1, your D1 will align to your T1's expiration date. Before the update, that alignment would go to the furthest expiration date available, even if that expiration date was 2 weeks out from the date. So I have a little example here. You get quite a few operators emailing in saying, hey, what happened? I only have a certification now for 2 weeks. So with this operator here, he did renew his treatment and wastewater treatment December 15th, but then added a distribution December 13th before the renewal. And now it had a life term at that time. It had a term of only about 2 weeks, which was possible pre-portal update. We don't want this. We want to avoid this since by standards you're supposed to have PDHs at least 30 during the effective date and expiration date of your certification. The expectation would have been for this operator to get 30 PDHs between December 13th and December 21st. Of course, we reversed this for him. We just aligned it to his other certifications after the fact, but we've had way too many of these incidents, and we want to try to avoid this in the future with this next update, which is already live at the moment. So starting the process of alignment, I did mention earlier, you either have to upgrade, which is adding a new certification, like you just passed your exam, you're adding a certification to your portal, or you have to renew. I did want to go over again the difference between upgrading and renewing. Unfortunately, operators do believe that when you upgrade by adding a new certification, all of your existing certification expiration dates change. It's quite the opposite. In fact, your new certification date actually changes. The process is a bit different. For upgrading, you don't need PDHs. That's why you can just add a certification and keep going. The certification fees are different for a new certification versus renewal. Upgrades can only be processed 1 year after a certification's effective date. So you have to hold, say, your C1 for a year before you can go up to a C2, or be approved for an early exam. And then upgrades must be done within 3 years of passing the exam. So in your effective date, your first effective date is always your exam date. So you need to upload that new exam to the portal within 3 years to get the full 3-year term that is allotted for a certification. Versus a renewal, you need PDHs in order to renew, which means change that expiration date for any certification on your portal. The new renewal fee is a bit more than a new certification fee. You can renew up to 3 months before an expiration date of a certification. And this is also a new feature with the portal update. Prior, you were able to renew at any point as long as you have the 30 PDHs. You can earn a certificate today, earn 30 PDHs in a month, and renew that same certification. We've eliminated that process, and now you can only renew up to 3 months before the expiration date. Certifications become inactive after renewal, after the 90-day grace period for certification. So these are the differences between upgrade and renewal. Just remember, the biggest one is if you're upgrading and there are no PDHs required, your expiration date is not going to change for your existing certs. Let's get into the alignment process currently. So not much really has changed with basic screens, but we do have quite a bit more information available to make sure that you make an informed decision when you choose to align your certifications. So you're going to still enter the same information, your operator name. I just chose this one because I love the Spider-Verse movie. So you're adding a wastewater treatment grade 1. You got your score and your student ID. This screen before does pop up. It'll say, do you want to align your certifications? But the prior version only gave you the option of align your certification to the furthest date available. Like I said, even if that was 2 weeks from now, or do not align and get the full 3 years. So the no part has not changed much. But the yes has, and we've added a bit more information as you go along, including this aligning your certification to a common expiration date may reduce your renewal fee and simplify the process going forward. We say may reduce your renewal fee, but it does. It definitely makes a difference since the first search is a certain price, which we'll go over later, and the second and third and fourth search are considerably cheaper. So selecting no in this new process the certification will automatically receive a full 3-year term. So my wastewater treatment here, I earned it, say, I think of July 15th of 2023. It'll now expire at the end of the same month of 2026. Um, and also here you'll notice the projected fee is 87. We'll talk a bit more about this later, but fees are expected to increase. So this module is showing the next fee increases um, with the second portal update. If you are a new operator certifying, as you've never had an operator ID, you've never certified with ABQ, the option to align will not be given to you. You won't see the screen at all, or they won't see the screen at all. They'll only get to put in their exam scores and then confirm with their summary page and move forward with payment. You won't see the screen until you get the alignment screen until you get 2 certifications on your portal. So what does change is when you do select yes to alignment. As I mentioned before, pre-portal, the prior version of the portal only gave you the option to go to the furthest available expiration date of an existing cert. So for my new wastewater treatment 1, in the old days, I would have only been able to align it up to this water distribution's date of 31/2025, whether I wanted to or not. With this new update, now you'll see every certification you have that is 6 months out or more, but within 3 years. So now you can align your new certification to any existing certification between the time of 6 months to 3 years. This way, well, we chose 6 months mainly because it is very possible, especially if you're attending these ADQ webinars during 30 PDHs in 6 months. In the last year alone, we've offered the OPCERT and the TA. We've offered about 70 PDHs. OPCERT alone, I know, offered 54 PDHs in the last year alone. So we chose 6 months because if you're using ADQ webinars and also taking training at work, it is definitely possible to reach 30 PDHs. But we didn't feel like it was fair to have an aligned certification of 2 weeks and say, yeah, go ahead and get that 30 PDHs. So that's the biggest change right there. If you have a certification here, say wastewater collection, that expired the end of this month, you would not see the option to align it here. You'll only see certs 6 months out or within 3 years. And the fee will be here as well. And this fee is just pertaining strictly to the upgrade. This is not the renewal process. Though you can align in the renewal, I'm only showing you the upgraded process. Second thing that's going to change after you've made your decision on the date will be the summary page. This here, your summary page will now confirm that you did or did not choose to align certifications, a new certification to your existing certification. And it'll also let you know the new alignment date here. So even though you took this exam and you passed it July 17th, this is the effective date technically since it's a new cert. Your new expiration date is 5/31/24. Like I said, you can have a certification period from 6 months to 3 years. Had I selected no, this expiration date would have been July 31st, 2026, but I'm aligning it to the certification of the water distribution. So it automatically will take that date. Oh, no, I took it to the water treatment, excuse me. I aligned it to the water treatment. And so it's going to take the water treatment's expiration date. All right. And then you'll move forward as normal. Didn't go over the payee option. I did on a previous webinar, but you will have the option to either pay yourself directly or send the bill to a secondary payee. All right, some special considerations for common alignment. If you have existing certifications, alignment can happen two ways. You can either renew first, which I do suggest renewing before you add a new certification, and then align the new certification date to the existing certification. If you renew today, two certifications today, and you earned a certification today, you won't be able to align that new certification to the existing ones because they will be within the 6 months expiration date. Sounds a little confusing, but you won't even see the option. If I had a T1 and a D1 and I had to renew it this month and it have not been renewed, my C1 would not even have the option to align. With that being said, you can still you can still upgrade that new certification. And then once you're ready to renew your D1, T2, you just align it to that new certification. You have a lot of free range on your dates of your certification now. So that's the main point I want you to take away from it. When given the option of dates to align a new certification, I would always just opt out for the furthest date available, unless you know you're not going to need that cert in 6 months. If it's just a quick job, you need a T1, and you don't really need it for too much longer. You don't want to pay for the renewal down the road, which I don't suggest, but I have seen some operators prefer to do. So just choose the furthest day out, just in case you need that T1 a bit down the road, further down the road. If your goal is to upgrade your certification on a yearly basis, I do not recommend alignment. You'll see your new certification time frame shrink slowly and slowly because once you start commonly aligning, that expiration date, the final expiration date, will stay with your new certifications until that expiration date comes to pass. So if you're upgrading yearly, if your goal is to be a 4x4, 3x3, or whatever, or 3x4, do not choose the option to align. Go ahead and give those certifications the full 3 years. When you're a 4x4, you have all four certifications, at a grade 4. You don't need to worry about common alignment at that point. Your expiration dates are going to stay the same, and during renewals, you will automatically get the 3 years. So if you're already at the top, don't even worry about it. You're good to go. I would not align a new certification to an existing certification you do not intend to keep. That new certification's expiration date, its term will be shorter. Once that certification you don't intend to keep expires, becomes inactive, you'll be spending more money in the long run. So, for example, if you're leaning more towards wastewater than drinking water, or vice versa, you don't want your collections or your wastewater treatment, or you don't want your distribution or your water treatment certs anymore. You want to stick to one side. Don't align a new cert to an existing one that you don't intend to keep. Okay. To align or not to align, there are a few advantages and trade-offs for alignment, and many of you have probably already noticed. I'll go ahead and just start with the trade-off. Your term will be shorter than 3 years. That is an automatic process. It's one that ADQ expects. So when I get the email saying, "Hey, I renewed. Why does my certification only have a 2-year term?" This is the trade-off with common alignment. The advantages are, with the same expiration date, your renewal fee is considerably lower. So the current fees are $150 for your first certification and $50 for each after. If your certifications have different expiration dates, each one of those certifications are $150. So for 2 certifications, you could be paying $200 if they're aligned, or you can be paying $300 for each certification. So the benefits, the cost benefits outweighs not aligning. Certification management becomes easier with less dates to remember. If you have a certification that expires at the end of July, second certification that expires at the end of September, a third certification expires, say, next June of 2024. These are all dates you're going to have to remember to go in. These are all PDHs you're going to have to align within these time frames. It is easier to align your certifications and begin. And now with this new common alignment update, you now have more control of your certifications, um, when they expire, how long they go, as long as they're within that 6 month to 3 month window. Um, if you're going to continually be upgrading, uh, the portal will allow you to manage your certifications easier, and you'll have more control over those expiration dates. So I will always advocate to align, considering the special considerations we just went over. So the main gist, uh, the process to commonly align has been updated, and I believe will be a lot simpler for operators once you go through the process yourself and see what you have available. Um, you'll have more options on the expiration date that you would like to take for your certifications, depending on your career aspirations and goals. Um, just keep in mind, no certification will be able to align to an existing cert that's going to expire within 6 months. We want to avoid a 2-week certification or a 3-month certification. And then throughout the entire portal update, we've added clear instructions on how to make informed decisions, not just with common alignment, but when you renew, upgrade, when you apply for early exams, and for reciprocity as well. All right, so now moving on to a few OpCert updates coming up. I'm pretty sure all of you have been, or most of you have been a part of the fee changes within EDQ, talks within the stakeholder meetings that we've had over the past year. So OpCert is going to see an increase in fees, and the lightly projected date is going to be August 4th of 2023. The portal right now for the new certification says 65, but you'll see if you add a new certification, that price will go up by 34% across the board for OpCert. Across ADQ in general for all of its services offered, but for OpCert 34% is the same number. And you'll see these prices incorporated in the portal starting around August 4th. Okay, so please be prepared in advance. The OpCert homepage is going to be revamped within the next month or throughout the month of August. We're adding a separate page on reciprocity, a lot more details, a separate page on the exam with more details as well. The How to Become Certified guide has been updated. Updated links, updated resources, and as we get more resources, we'll be updating it on a regular basis. The homepage will be a bit more concise on information. We want the homepage to be whatever you need, and then a link to wherever you need to get to. With all the information on the side, if you need to download that How to Become Certified, if you need the dashboard, if you would like to look into the talks and the agendas that the certification committee have been involved with over the last year of being formed. All that information is available to you. And with that, are there any questions? Common alignment, certification, or anything of the like? All right. I don't see any questions here, but if you have any, or you have come up with anything, or you need a follow-up, please contact the OpCert program, 602-771-0100. If you can't reach us, we're probably on the line with another operator. There are 6,000 plus operators in Arizona, and any one of them can call at any time. Please leave a voicemail if we're not answering. Or you can also email the OpCert program at azopcert@azdeq. Okay, that being said, we're going to go ahead and switch to our next presentation, Jason Bobko. Jason, are you on the line?
I am. Good morning.
Perfect. I'm going to go ahead and switch the screen to you. Looks good.
All right. Thank you very much. Good morning, everybody. My name is Jason Bobko. I am going to talk today about some operational considerations for treatment plant startups. I am the current manager of the drinking water engineering review, technical assistance, and operator certification programs at DEQ. I've been with DEQ for 6 years now, And for the first 4 years, I was actually in the inspections, compliance, and enforcement unit. So some of you may have heard of me from there or from the engineering review or TA part. But I've been in the drinking water industry for the last 24 years. I know it kind of dates me, but it's spent 6 years working in the water quality lab, 11 years in operations, and then the remainder of the time here at DEQ. I have my BS from the University of Connecticut. I did obtain my certificate in water management from Gateway College in New Haven, Connecticut, because there's a Gateway College network across the country. Very similar program to what the Phoenix Gateway College offers. I have my master's degree from St. Xavier's University. I do hold my grade 4 operator certifications in water treatment and distribution, and also my grade 1 certifications in wastewater treatment and collections. And in my career, I've been very fortunate to have worked at 8 different surface water treatment plants, ranging anywhere from 10 MGD all the way up to 80 MGD facilities, um, both in Connecticut and in Arizona. So I'm very fortunate to have a lot of exposure, a lot of experience, and I never said no whenever something had to be done. If we had to go down in a pipe, I'd go. We had to go down and scrape sludge, I would go, because that's how you learn. That's how you really get a good understanding of the processes. So today, I'm going to talk to you about the importance of your operations staff. Like I said, I've been responsible for 8 surface water treatment plants. 2 of them were actually startup plants, so they were built from the ground up. And then another one was an expansion, and we still maintained operations during that expansion. But there is a difference that what new builds versus what expanding an existing plant and operations, they have different stressors and require different mindsets. You need to have responsible and responsive engineering firms, contractors, and vendors. There are a lot of moving parts during this time, and mistakes will happen. But with proper planning and preparation, hopefully most of those mistakes can be avoided, because mistakes are costly. So once the engineers and the contractors leave, the operations staff takes over. This is a learning experience for the operators, the supervisors, and the managers. By not taking advantage of the opportunities provided during startup, you're missing a vital component to the continued success of the facility. And these facilities, whether it be, a $50,000 arsenic treatment skid up to a $120 million surface water treatment plant, it's a significant capital investment that's being made by, if you're the owner, by you or by the owner of the system itself. And you got to make sure that it is being run properly to ensure the longevity of the system and that it's meeting what the purpose of the system was designed for. So the agenda, what we're going to talk about today, we're going to talk about some safety considerations. We want to demystify the process, right? Nervous staff will create and can create their own hazards. So you want to educate them as much as possible in every component of the process. So if they see something out of the ordinary, they don't overreact or underreact and allow it to get worse. You want to select competent and confident staff in order to create a depth of operational knowledge. You don't want to let the vendors off the hook, okay? There'll be different vendors involved in your build, and you want to make sure that you're holding them all accountable, because there will be finger pointing and there'll be a lot of excuses. But who cares about their excuses? You just want to stay focused on your needs and your needs of the facility. Make a point of sitting staff down for, I call it story time, but really it's about reading those manuals, review the yard piping diagrams. Those are unbelievably important. If you don't have one, I suggest you try to find it. You might have a file of it or get one made. Yard piping diagrams can be the key to stopping a severe flood, avoiding an MCL violation, or just producing water that's going to hurt people, right? If there's a valve that got inadvertently opened when it should have been closed or vice versa. You want to be able to pinpoint where all your piping, all your valves are at your site as soon as you can. And a yard piping diagram will help you do that. Discuss lessons learned. Okay, I'm going to discuss that with you today. Again, I've been very fortunate in my career to have seen a lot of stuff. And actually, sure, I may have caused one or two minor things like flooding faults, but I've seen a lot of other things go down. And I've been fortunate to have been there to experience it, to see the response, how it happened, and how the process to fix it went out. So I'll be talking about some of that as well. So those lessons learned I'll discuss, and so we will hopefully be avoided in the future startups. Okay, what is it? And for those paying attention, please, I'll give you a second or 10 seconds. Throw it in chat. What do you think this is? I'll tell you, it's a surface water treatment plant, and it employs ozone. So if anybody wants to join in the chat, go right ahead. So we were driving up on this cloud of gas in the early morning hours. You can see it's just getting dusk, and the staff was trained on the use of liquid oxygen, but they had never actually seen what happens when the liquid oxygen vents the atmosphere, when it overpressurizes and just blows the vent. So this is what an overpressurized liquid oxygen tank venting looks like, right? So staff arrived on site early morning, they saw this. This is a critical component of the ozone generation system. And after coming on this and panicking, they did figure out afterwards, and we told them what this was. So, pay attention when you see those no smoking signs, pay attention to those. You never know what you're going to come upon when you're driving up to a facility. And this is all just oxygen bleeding off. Which brings us to the safety considerations part. So know what chemicals are being used, liquids, gases, solids, granular chemicals, you have powdered chemicals, and know what their properties are. And how do you find those? Well, you use the safety data sheets, the SDSs. And you should have a HAZCOM plan as well, hazardous communications plan. Know if there's an inhalation hazard. You have chlorine gas, ozone, fine sand, carbon dioxide, powder activated carbon, all inhalation hazards. There are physical hazards. There will be moving parts, pinch points. Some parts will have extreme cold, others will have extreme heat. So especially out here in Arizona, we still walk around these facilities with, we have a lot of them have aluminum railings, which are not as hot as the steel railings, but we also, for some reason, they keep putting fiberglass enclosures out there, and they just don't last. If you're unfortunate enough to have leaned against a fiberglass enclosure, or you saw something out there is like rubbed your hand over it because it was all like oxidized and powdery, and then later on you're covered in those fine filaments. You know what I'm talking about. So again, that's more of a physical hazard, but be aware, okay? Know what oxygen deficient environments can be there. Carbon dioxide cylinders, you have cylinders on them, right? Do you have bulk storage? Because you can get bulk storage of solid carbon dioxide that will just sublimate and you get the gas off of it. Or you can get the cylinders. Okay, either one will do, but know what you have. Do you have ozone contactors? Okay, and know how they operate. Is it a side stream injection? Is it diffusers? What do you have? Okay, all ozone is going to be generated on site anyway, so you should be familiar with that. Wet GAC, even wet GAC can produce an oxygen deficient environment. So be aware if you're ever down on top of a GAC filter and it's slightly wet, just understand that it could be absorbing some oxygen from the air, and it could be a low oxygen environment, but you should have plenty of ventilation anyway going there. So but these are hazards. Be aware. Okay. Always use the right PPE for the job. All right. PPE, the very first P is personal. All right. Personal. So in my opinion, don't be sharing your goggles. Don't be sharing, obviously, gloves, masks. If you have ventilators, if you have just an air purifying respirator, that's yours. Okay, make sure you take care of it. It's up to you to make sure your stuff is in good working condition when you need it.
Excuse me, Jason.
Yes.
We've got a few in the comments saying it's a bit difficult to hear you clearly.
Okay. I can move closer if that helps. Did that make
Let's
it
see how
any
that
better?
works. Let's try that
Yeah.
one.
Okay. Good. And thank you. Sorry about that, everybody. Yeah, and good job with the oxygen leak from Nathan. Yep, liquid oxygen spill from Jason. Good job. Sorry, Paul. I could try to. If that's any better, please let me know. Okay. So next, we're going to go into selecting staff. So after having sat through hundreds, and I do mean that, hundreds of operator interviews, um, experience in the water treatment, and water treatment does not necessarily mean that working 25 years at one facility counts as 25 years of experience. Because some people may just know what a button does, but they know to push the button, but they don't know what happens after that or why. So you need to look for people with different experience levels and an understanding of the treatment process. Some key characteristics to look for when hiring treatment plant staff include flexibility, innate water plant knowledge, readiness and willingness to get involved, an inquisitive nature. You want engagement. You want them to come there and be completely engaged in the process and be curious. And they need to have an ability to visualize the process, to understand where one flow leads to another and so on. They need to know, here's a key thing, they need to know what they know, and they need to know what they don't know. And that means they'll ask questions. I have had experience, and I say this, quote unquote, much better in person, but I've had experienced applicants not know what the pH scale means, or even what it is, or be even able to perform a chemical dosage calculation. You really don't want that when you're talking about a treatment plant startup. Um, this is not where you just want, um, butts in the chair or a you get what you get kind of hiring moment. You don't want that here. You really do want the best people you can get to be operating this facility. Oh, thank you, Paul. I will try my best to make sure I keep closer to the microphone. All right, when to hire staff. And this is one where whoever's going to be in charge of hiring is going to have to be talking with your managers, be talking with the budget people, be talking with your HR staff. You can't wait until the day the plant starts up to hire people. All right, hiring staff during construction is imperative. They need to learn the facility from the inside out. You should all know that one person that can tell you right where a pipe is, okay, or right where that valve goes or leads to. And if there's water flowing out of an open channel, where's it coming from? There's going to be somebody who knows that, and you want to make sure that at least one or two people know that. So you got to convince your hiring authorities, right? The first day of operations should not be the first day on the job. Okay, you should stagger their starting. Coagulation and flocculation look similar in most processes. Dissolved air flotation, ballastic flocculation, conventional sed basins. Uh, don't be mystified by a new or a relatively unknown process. They all basically achieve the same thing at the end. This is where the operational common sense comes in. So you need to know what to look for. You need to know your chemicals and the operational range of your chemicals. There's some, I say it like this. So if anybody in the audience sells ferric chloride, I apologize in advance. Not my biggest fan. I'm not the biggest fan of them, but it's kind of like snake oil because they come and tell you this stuff operates, from 5.5 to 10.5 in all sorts of temperature ranges. You can use half as much as you do with alum and all these other things. But guess what? Ferric chloride is a horrible chemical. It's extremely low pH. It eats everything. It stains everything. It leaves a residual, and it contains manganese. So it's just horrible stuff. And an operator, if they switch from alum to ferric or ferric to alum, hopefully flushing systems or having completely different injection systems totally. If they dose 20 parts, they'll dose 20 parts, whether it's alum or ferric. So I'm not a big fan of ferric. All right. So that's my spiel on ferric chloride. Not a big fan. I've had it. We switched away from it. And also, hey, if you're an operator and somebody comes to you and tells you, "Oh yeah, go ahead, you can mix ferric and chloride. They're both coagulants." Don't do it, because what happens is that happened, and we were told to do that, but I said no, and I took a sample of both and I mixed them together in a beaker and I showed them what would happen, and it just crystallizes into this gooey gel. And so imagine if that happened in your 10,000-gallon storage tank, or if you just filled up your day tank and you had a little bit of leftover, one or the other, and then all your injection points, all your injectors and lines and pumps got clogged up with this stuff. Then what? Okay. So again, know your chemicals, folks. Know what to do. Where do you find information on your chemicals? Where do you find incompatibilities? Your SDS. Okay. Okay. Vendor training. So the process has already been piloted somewhere. Your process, right? It could have literally been piloted at your facility before you even got there. Okay. The process, it's been piloted. So review those results. Okay. You want to get the specs for the process. Okay. If you're told, if you're looking at the specs and it says you need 30 inches of GAC, and hey, you go out there, you measure it, you find 20. Oh, ask, fine, what happened? Where's the other 10 inches of GAC? Okay. If you're out there, and again, I was there, we had a belt filter press being put in, and the contractor had buried up to a certain point, 8-inch line that was supposed to be cast iron, and they actually installed PVC, and they had actually filled up to the surface, backfilled, and then they put a cast iron leg coming off the top, and we dug down just a little bit and we found the PVC. So yeah, that was plant staff that found it, right? The engineer on site that was doing inspection, he probably would have found it. We were there first, but we found it. We said, no, this is supposed to be cast iron. So they had to go and change it. So those types of things, they're not considered change orders. It was just the company, the construction company, contractor. Who knows? Maybe they just misread the prints. I'm not sure. But just anyway, know what you're supposed to be getting. So you want to review the results of the pilots, right? And look for specs. Know what to look out for visually. Okay. This is going to be like a new normal for a lot of your folks, right? So two of my startups were DAF plants, dissolved air flotation. I cut my teeth in the first one in Connecticut, and it's definitely a different process. Instead of settling the solids after coagulation, you're floating them, and that's it. It's pretty simple, right? But you got to get your head around it. And when I came out here, I started at a DAF plant that was brand new, and we were instantly able to make some good operational changes to improve the process. Just based on, well, one, my experience, what I know, and two, you really should not get a whole lot of sedimentation in your DAF basin. You shouldn't. That's the whole point. And we were getting a lot of sludge. So we made some changes, and we were able to correct that process. But again, it's knowing what to look for. That's the whole process. Don't let your vendors off the hook. Okay, use them to conduct as many training sessions as you need. It should be built into the contract when you're designing the facility. What type of support are you going to be getting from your vendors? Okay, it all should be in that initial scope. So make sure you hold them to it. And if you have questions, ask them. If something's not right, bring it to their attention. Remember, what's being built should last anywhere from 20 to 30 years. and you're making, and I'm talking about the larger systems, right? Even the smaller systems, what you're doing there, you're getting a skid mounted arsenic treatment system, very common out here. So, what's the life cycle replacement on that? What's the expectancy for that equipment? What should you expect out of that? That should all be in your O&M manuals. Okay, just make sure you look it over. All right, again, segue into the O&M manuals. So with all the new equipment, because you'll have a ton of new equipment, you're going to need to know where to find all the necessary information for proper operations. How hot should a motor be while running? Okay, it's a little different out here because of the sun, but back east, if you had a high efficiency motor, you put your hand on the motor while it's running, and if you can hold it there for about 3 seconds without having to tear it away because it's hot, and that's okay. That's how hot they should be. Here, a lot of we try to cover a lot of the turbines, the vertical turbines, because boy, it's just so hot. I mean, that's just going to make it even worse. So know that. Know how many drips per second. If you have packing, how many drips per second should the pack be dripping? Okay, it's all going to be there in O&M. Again, it's nothing. It's not a mystery. You just got to look for it. And you got to say, does the pump have packing, or is it a mechanical seal? Yes, I actually replaced a transfer pump with it was one that had lubricated packing to one that had a mechanical seal, and didn't realize it, and as soon and I realized I didn't have to hook up a lubrication line, but what I didn't realize was that the pump had a solenoid hooked up to it, that when the pump started, the solenoid opened and water would shoot out, and that was for the packing. So when we started up the transfer pump, water just started shooting out of this line, and everything was fine. We were able to figure it out, but one of those oversights, and honestly, we just kind of did it. So we were just in operations. We tried to get the transfer of the chemical done faster. So that was it. So you got to know, does a red light mean the equipment is running, or does a green light mean the equipment is running? Again, we had a schema back east where wastewater treatment facilities, we call them publicly owned treatment works, they had a red light meant open, okay, and green light meant shut. And those are on your gauges and your dials and your SCADA. Out here, and even my surface water plants were different. So green light meant open, red light meant shut, because you wanted to know, especially in a wastewater facility, do you have valves open? Is the flow moving? Where is it moving? You want to be aware of that. And that's, like caution, this product is moving. So just know that, know what your schema is. Also, know what the operating pressure of your chemical feed pump. Okay. Your chemical feed pumps are extremely important to your process. And you need to know. You need to know what the pressure is. You need to know where the nameplate is for that pump. Every one of your chemical feed pumps, every one of your transfer pumps, even your vertical turbine, like well pumps or water pumps, they should have a nameplate on it, which should have, minimum amount of information, horsepower, maybe flow, power requirements, all that stuff. It should be on there, date of manufacturer, the manufacturer's name. So know where that is. Know what your spare parts are. Know the installation requirements, operating environments. Okay, all these factors are in your O&M, so read them. Some of the biggest problems that I've seen have actually come from not reading the manuals, and that's just a fact. So make sure you have good manuals, whether it be electronic or paper, right? Have them ready. Have an actual binder with them. Make it where it's like an annual review. Also, use your O&M manuals to create your standard works or SOPs. And we'll talk about that later. Okay, we talked a little bit about yard piping diagrams earlier, so they're as important as the O&Ms. The staff must be able to identify where the pipes are throughout the process. Sample line locations are a priority. So your sample lines are really bringing your process control samples up to your analyzers, whether it be in the lab or out in the plant or in different outbuildings, what have you. You need to know where those sample lines are to ensure, one, that you can fix it if the flow suddenly stops, and also to verify you're getting the correct sample. Okay, so, and one way to do that is you actually go to the point in the process, you do a grab sample at that point, and then you compare it to what the analyzer is saying that's supposedly reading from that point as well. And you should have pretty close results. So that's one way to verify. Yeah, so you do need to know that when, especially when the analyzer has no flow or it's giving bad readings, or worse, when you want to know where all that water, right, all of a sudden there's a ton of water coming from somewhere as you walk downstairs in the pipe gallery and open a door to an outbuilding and there's water everywhere. You want to know where's it coming from, or even worse than that, like if there's chemicals. Okay, if there's chemicals spilling somewhere, you need to know how to go isolate, shut that off, and isolate that. So you look at the diagram, right? Your yard piping diagram will have that information on it. Okay. It'll also include cooling water lines, chemical day tank overflows, any kind of process control valves. So your operations staff must know, they must know where each flow goes. That's the only purpose of a valve, is to control flow, right? They need to know where all the flows are going. So what I have up here is a typical example of a yard piping diagram. And this is really an overview. This is a larger one. Like it just shows the entire process, but you can get down to the ones that you'll see in your facility should go right down the details of chemicals, feed lines, sample lines, etc. It should have everything. Okay. So the difference between vendor needs and operational needs. Okay, so I say beware packaged components. They're not bad. Just beware, be aware of them. Vendors will always prove that their product works. Okay, you ever see those infomercials? I'm sure you have, where the person's trying to use a sponge and they're fumbling it and they're dropping it, like, oh no, and then all of a sudden the ad man comes out with, oh, but look at this new sponge, and it's just the stupidest thing. Well, be aware. They'll always ensure their product works. Okay, but it may not work for you. In order to meet some performance standards, vendors will use their own proprietary chemicals. They're costly, they're not readily available, and there's usually only one provider, and they'll do this just to ensure their process works. So be specific, again, up front, on what chemicals you want used in your process. If you have a particular polymer you want to be used, put it in the spec. The same thing goes for your aluminum sulfate, your ferric chloride, or anything else. Okay, don't get stuck with using costly proprietary chemicals year after year, or even just for the very first year because you're under warranty. Okay, they will do that. They'll make you use proprietary chemicals until the warranty runs out. So at the end of that process, that 1 year, if you don't want to use their chemicals anymore, you switch to another vendor, and all of a sudden something happens with your process. Well, they don't care because they made the 1 year warranty with you. So do this. Don't get stuck with those costly proprietary chemicals, just so you don't get blamed when the process fails. Okay. No, does your ozone generator simply work? Right? Does it turn on, or does the ozonation process work? Because there's components, right? There's different components to your ozone generation system. There's the ozone generator, and is it just using atmospheric oxygen? Is it using compressed liquid oxygen? Is it using gaseous oxygen already prepared, already ready for you in bottles? And then is it going to the injection point? And then is it actually oxidizing what you need it to oxidize? So that's the ozone process. So you want to know, does each component work, but does the whole process work together? So analyze that process. All right, does the dosage produced meet your raw water needs, your intermediate ozone needs? Know that and make sure and test it. Kind of like building a car. And folks that work for me, they know I love cars. So it's like, yes, you have an engine. The engine starts, it runs, but oops, they forgot the drive shaft. What do you do? I mean, so you want to make sure your whole process works in conjunction with each other. So whether it's a DAF unit, a sand ballast population unit, your conventional sedimentation, or your direct filtration, the overall post-treatment process, means after all your treatment and filtration, it should provide the optimal filterability in order to optimize your overall plant performance. So whatever's coming out of any one of those units, when the time gets to your filter, it should be all about the same quality to go through your filter, because that's ultimately what you want to do. You want to have that that quickest filterability you can, so you don't blind your filters, overtax your filters, what have you. So just know your process, okay? I talked earlier a little bit about your standard operating procedures, whether they're called SOPs or standard works. So use this time as well during this startup process for documenting everything, okay? You want to shadow the staff, document procedures as they go along. This is your own staff, right? Let's say you're the foreman, right, or you're the lead operator. You're going through the startup processes, right? Have somebody, could be you, could be someone else, walking around and documenting the procedures as people go through them. Okay, this is important because you need to know, do I turn the left valve? Do I turn the right valve? Right? How many turns is open? How many is it clockwise? Is it counterclockwise? Stuff like that. It'll be in your yard piping diagrams. It'll be in your O&M manuals, but you'll want to know, so you document that, right? And this is where your standard operating procedure. What is an SOP? It is the best, most current process for doing something. Okay, that's what it is. And you want to make sure that you have it documented. You want to make sure that you're updating it regularly, and you want to make sure staff are trained on it. Every one of the standard works I have that I create here at the agency, we sign off on it, and we also have a change log at the end. And that means that if anything's changed in that standard work, it's documented. And then we go through it every 6 months, really, is what our target is. And then annually, of course, is for sure. We're just reviewing those standard works. Okay. So when you're documenting those procedures with your staff, use that information, right, to develop your comprehensive, and I mean comprehensive, SOPs. So if you're taking a 10-step process and truncating it down to 2 steps, that's not comprehensive. Okay, that's not comprehensive. You want to document those 10 steps, okay, because there will be a day where somebody new has to come in and follow that SOP. And if you're just skipping a very key little process that you overlooked, or you said, oh no, I know how to do that, so I'm not even going to include it. Well, you're just setting others up for failure. So make sure they're comprehensive. Use them for annual refreshers, for new staff training, of course, and for reference guides, right? When you have those very seldom performed tasks, like you have an annual shutdown or anything like that, that's when you pull out the SOPs and review them first, so you can get familiar with the process. Because what you don't want to do is stop in the middle of a valve that won't shut or a pipe that burst, and then you'll have to reference a standard work because you didn't do it before you started the job. Okay, you want to make sure you're looking at them first. So they also provide a good paper trail documenting what staff does when operating the equipment. It's very helpful when there's equipment failure and the vendor comes out and says, you, plant owner, operator, staff, you forgot to torque a mixer blade, or you used the wrong oil, right? Well, if you could identify with your documentation that you have documented correctly the information you were given and the O&M and the training, you show them, no, we did it. This is what you told us to do. This is what we did. Well, then now it becomes the vendor's issue, okay? And I say mixer blades, yep, had mixer blades fall off the shaft and the flock basin. And guess what? The motor was turning, the shaft was turning, the water wasn't. So we were able to identify, well, there's something wrong here. Okay, was it normal? No, it wasn't, but we know what normal was. You understand? We knew that normally, if the mixer's turning, the motor's turning up on the deck, and the shaft is turning, then we know that the water should be moving beneath our feet, and it wasn't. So of course, you can't see it, but process of elimination told us there's something wrong. And sure enough, the impeller had fallen off the shaft. So know this stuff. Know that you know the process and what it's supposed to be. So here's another, what is it? So again, that was great last time. Thank you all for participating. See if you can see what you think this is. take a couple of seconds here. It's a funny one. Well, I'll tell you one thing. What you're looking at is the inside, excuse me, the inside of a 48-inch pipe. So one thing, it was not supposed to be inside the pipe. So what is it? Well, ironically, it is the exterior plastic liner for the buried pipeline. So this is the interior of a 48-inch, 14-mile long raw water transmission main. Construction material was flushed into the plant inlet strainer basket, and this obviously it stopped the flow entirely. It got caught in the strainer basket before it went into the actual plant process itself. But here's the best part. This is what it read: raw water line below. So basically, it was supposed to cover that line after it got installed and then buried. So if you're ever digging, it would be layered above the pipe, like probably a foot or so. But so if you're ever digging in that area and you come across this plastic liner, you would say, "Oh, wow, there looks. I think there's a raw water line below." So how'd that happen? Who knows? Um, improper installation, improper inspection. Um, Somehow, a big wad of this stuff got caught in that pipeline. So again, it was caught though, luckily, by plant staff when suddenly the flow stopped. That was an indication that as simple as it sounds, they knew that all the valves were open and the meter was calling for a flow and nothing was happening. So they knew to go out there and check. And again, it's just about having that type of engagement and knowledge and what normal looks like that made them successful to figure that out. Okay, this is all about lessons learned. Um, so this is major flooding of a pipe gallery during a leak testing procedure. So way in the back in that circle, sorry it's not a better up close picture, I guess I could zoom, but that is the top rung of a 6-foot step ladder. That's what you see there. So there's about 5 feet of water in this pipe gallery. The flooding went on for hours, right, until the contractor noticed that the leak test was failing. So what they had done was, they're trying to fill all the pipes, right? Trying to fill the pipes and take a certain amount of volume. So they knew it's going to take, say, 3 hours to fill this pipe, and then they could do a pressure test and a leak test. Well, they filled for 3 hours, and they weren't getting any good results, nor were they sending people around looking. Okay, they didn't send anyone around to look to see. Okay, go check. What could have counted to miles of piping, right? Go check and make sure there's no leaks. If they had just done that, this could have been prevented, right? Because they were just waiting for their 3 hours. Let's fill and go to lunch, come back, and it should be done. And this is what happened. There were 2 causes to this, right? One was the 60-inch 5-foot isolation valve. Somebody forgot to close it. That's it. One simple thing. And there was a blind flange that was not secured, just wasn't bolted down. It had like one or 2 bolts or something in it, but it wasn't bolted down. But again, the isolation valve would have been the key there. So the takeaway: be sure you have positive shutdowns on your isolation valves. Okay, walk the area, inspect all the areas that could be impacted by the open valves during the procedure, and station staff around the plant to be the eyes and the ears when your commissioning occurs. This happened during commissioning. Okay, so it's easy to say in hindsight what could have happened, right? But that's why we call them lessons learned. That's why we have presentations like this, and that's why you go to different trainings and you get professional development hours to maintain your certifications, because you may not see this. Okay, you may never see this in your life, and that's okay. I hope you do. I hope not like the errors, but I hope you see the commissioning, the building of new facilities, because it really is a wonderful experience. But just know, hey, maybe one day you'll say, hey, you know what? I remember I was watching a presentation and they said we should check valves if you're going to do this. So why don't we walk around and look for anything that should be closed that's open, or vice versa, and look for leaks. Maybe it'll hit you, okay? And you'll save a day. You'll save 8 mag meters, recirculation pumps, thousands and dollars of electrical panels. Okay, maybe you'll save that one day. Maybe you'll just prevent just a minor flood. Who knows? But you know what? It's the takeaways. That's why the professional development hours are required, and that's why we like to do them for you. So this wiring harness was found to be loose inside its enclosure. And the pump had started and it ran for a pretty short time before it just arced out and fried. So again, improperly secured wiring harness. This one was harder to identify, folks, because it was behind the panel. Right? This is a vertical turbine pump, and it was behind the enclosure, so you really couldn't see it outright. Only when the pump shut down, when it should not have, right? So here again, it's calling for the pump to run, it's not running. No feedback, nothing. So, and an electrician was called out for this one, folks, okay? So understand, right? As an operator, I don't want you and your management should not want you to go out there and start messing around with electrical stuff, okay? Follow lockout tagout, follow safety procedures, okay? 480 volt 3-phase is nothing to mess around with. So make sure if something happens like this, you call out an electrician to go check it out. Okay, that's the key. So you want to make sure you're safe. But yeah, this one again could have been avoided. Yep, right. So you got to make sure the electrical contractor who's out there, because there's going to be a lot of subcontractors. Someone has to hold them all accountable, and it steps up the chain. And ultimately, like as the operator of the facility, you have a lot of power at this point. You really do. You could shut it down, okay, and make sure things are right. So remember that. So this one, all the stuff you see here, gosh, I mean, there was a wallet, a hammer, there was some keys, I think, a couple of gloves. So all this was actually found in several finished water reservoirs after having been in service for 6 months, right? We had drained the facility, drained down the storage tank, and went down. And some people in the audience, I know I looked at the audience, some people there, Steve, should know where this is taken. This is all retrieved by plant staff, okay? And that is a 20-foot extension ladder directly under the reservoir hatch, okay, used by the contractor when they exited the reservoir. They exited the reservoir and left it down there, shut the hatch and walked away, okay? You'll notice the stains on that ladder, right? The bright orange is supposed to be the color of the ladder. The stuff below it, guess what that is? The facility started using ferric chloride, and when they first started up, because that's what they were told would work best. And look what it did to that ladder. Just, again, ferric. So what we found inside finished water storage tanks, finished water reservoirs, FWRs, whatever you want to call them, ladders, buckets, tools, right? It's all about they had just waited one moment and verified. Literally, all they was open that hatch and see that there's this giant ladder there. They at least could have pulled that out. Okay. This one, this 2x4, it was used to prop open a slide gate because this particular facility, the finished water reservoir and the pump station were attached to one another. And the slide gates were there to isolate the two. Well, we could not isolate this reservoir, just no matter what we did. So we had to get it down, the volume low enough to go down inside and find out what was going on. And this is what we found. This 2x4 was used to prop open the slide gate. So this combined with the extension ladder, combined with the bucket full of stuff. So what's the lesson here? Well, the final inspection was rushed. That's the lesson learned. Okay, oversight needs to be used before any part of the plant is commissioned. Any part of the plant. This one, they had an opportunity in 2 places: inspection of the finished water reservoir and inspection of the pump station. Missed. 2 opportunities, obviously missed. Okay, what could have happened? That worst case, possibly that 2x4 could have become dislodged, and where would gone, right? It could have gone into the pump, right? Is what it could have done. And then talking very costly mistake, very costly mistake. So could have been avoided. All these things that I showed you could have been avoided with just an additional step of a final inspection and a walk around and things of that nature. Okay. So in summary, right, if you write hire operation staff, you will have a better outcome. That means right hiring at the right time, the right person, right? That's what you want, the right certification levels, the right credentials. That's the right hire process. Don't just hire for right now. You want to right hire. You also want to follow training and develop your SOPs. You, in this process, you're setting yourself up for success now, right, as it starts up and down the road. And you will learn more in that first year of operations than in the next 10 years. Okay, that's the fact. And you'll make improvements. You'll be documenting what you need to know to say, okay, you know what? Yeah, the way the engineer designed it now is fine. However, we can make some improvements on our end to make it easier for maintenance purposes, which is sometimes overlooked. I will tell you that sometimes maintenance is overlooked when designs are being implemented. So that's another reason to have your staff involved, so they can have input on maintenance. So if you're looking at a dissolved air filtration basin that has a false floor that's only has a 3-foot ceiling, geez, maybe you want that a little bit higher. Maybe make those false floors removable instead of permanently welded in place. Again, somebody here in this audience should know what I'm talking about if they're paying attention. So, because it's a shared facility. Anyway, so know that, because at the end of that 1-year period, guess what, guys? It's yours, right? You don't have to worry about the warranty anymore. You're the operations staff. You know what you're doing, and that's just the key. Have confidence. Know what you're doing. All right. You're the ones going to be running that place. You're the ones going to be responding to emergencies at always 3 in the morning for some reason. So it's up to you. Okay. Provide your staff with the readily available information. Okay. You want to start them on the path of self-sufficiency early on. Okay. You don't need learned helplessness, folks. Learned helplessness. Okay. You all know it. You've all seen it. Don't allow that to happen. Use the information provided to give your staff all the information and confidence they need to make good decisions. Okay? Define who needs to know when and what. Okay? You don't need your staff at a 24-hour-a-day plant calling at 3 in the morning because they can't turn a light switch on. I'm just saying, that's ridiculous. It's happened, but it's ridiculous. You don't need that. Okay? They have to have a level of confidence to be what? To be what? A good operator, to maintain certifications, to be protecting public health. This is the responsibility operators have. I take it very seriously. I did it for many years. I love operations. I was very fortunate to come to DEQ and have the operator certification program under my management. And with Ebony, Ebony's been fantastic. Noah handed it over fantastically. You all know Noah. So we are in a phase of improving and offering as many good opportunities as we can, both in person and both through these types of events. So, let us know if you want, what you want to see, what you want to do. We have many events planned throughout the state now as well. So again, questions and anything you want, just let us know. We're here to help. We want to make your job, we want to make you as prepared as we can for your job. Okay. So, and also don't back to this, don't let your vendor off the hook. Okay. If they're like, oh, stop calling me, say, no, get it right. You get it right and I'll stop calling you. Okay. That's what you want to say to them. And always make a point of allotting time for your staff to read the O&M manuals, review them. Okay. It is not a waste of time to sit there in a break room for an hour and start going through a chapter. It is not, because what you as an operator, what your management needs to understand is you're gaining that knowledge, and you can take that O&M out into the field and you look and go into the pump station, right? Figure it out. You can do that. And that's fantastic. So lessons learned that in my life, in my experience, is always involve staff in the startup procedures. Okay, the more eyes you have, the better. Like quite honestly, there are so many moving parts and different components and different just processes that not everyone can be everywhere at once. Okay, no one person can be everywhere at once. You really got to have multiple eyes on it and trust. Okay, and another takeaway too is if it doesn't look right, it probably isn't. And that's where familiarity with the process comes into play. Know what you're dealing with here. Okay, know um, if it's simple things like know what it looks like when your flocculator is mixing. Again, example from earlier is the impeller fell off. Everything else looked fine. Also happened with a sludge pump as well, a sludge rake. Everything looked fine. We couldn't see the rake moving because it was cloudy and murky, but the motor was spinning. It turned out the shear pin had sheared, um, and the sludge just kept building up until we had about 8 feet of sludge in our shed basin. And it only got noticed when we shone a light down through it and we found about a foot below the water, the clear water, was a layer of sludge. So again, you got to know what normal looks like. So I really hope that this is a good experience today. Um, like I said, I've been very fortunate, and I want you to be fortunate and be able to see a lot of stuff. Um, we have about 10 minutes left on this time. So if you have any questions, please ask.
Hello, Jason. Thank you. Very, very great presentation. Um, Nathan provided some feedback. Great presentation.
Thank you.
We do have another question, looks like. For water systems that are constructing surface water treatment plants for the first time, does contract operations for the first few years have any advantage to taking on operations themselves? Should you contract or should you not?
Yeah, I get the question. Um, so for let's say it's a bid, build, operate type of situation, and the company came in, pick any engineering firm, and they designed it, and then they build it, and then they run it. Um, having for them to take on a long-term operations of it, I mean, I always prefer that the actual owner of the facility is the one doing the operations, and I'll tell why. But this is my example, and it's not set in stone. This is not what everybody does. However, what we've seen is that these type of operations, um, the contractor that's running the facility will allow equipment to run to failure, and then the owner has to pay for replacement instead of the owner just doing proper maintenance on things and allowing them to run the full life cycle. So it's kind of like, I mean, again, I'll use a car analogy. You rent a car or you lease a car and for 3 years and you don't do any maintenance on it whatsoever. And in 3 years, you turn it in. Now the dealer has this garbage car that's never been maintained, and it's up to them to fix it. So I wouldn't say there's an advantage unless that contract operations team is actually using their budget and doing the proper maintenance and making sure that they're running the facility for the lifetime of the expected life of the facility and not just for the lifetime of their contract. I've seen it. I'm not going to name any names, but there are a lot of contract operations out there. Some do a good job and some do what I said, which is they just run things to the point of failure, and then the owner has to buy new equipment. And what that does, it just gives that contract operator, we stayed within budget, right? We ran the facility within budget of what we were told and agreed upon prices, and then the system itself is one left holding the bag. So I'm not sure, Cal, if that was Cal Ramon's asked that question. So I've seen both, I have. And the one I like the best, obviously, is where the owner of the facility takes responsibility and has their own staff working there. Even if they're working in conjunction with contracted operations, that's fine too. But you really need to have that internal knowledge base built up of that facility.
Thank you very much, Jason. We did have one more question from Stewart. Shouldn't contractors be liable for 1 year? Therefore, the 1 year marks the owner has complete control of the facility, which is his understanding.
Yeah, Stuart. So good question. And a lot of that has to come with just like a manufacturer's warranty. So there's some facilities out there that say there's a brand new package membrane plant that got put in, and the manufacturer will give a 1 year warranty on it. The contractor will support and give that 1 year warranty as well, right? Just to back up what the manufacturer is offering. And it really comes down to what you contract. Okay, you could actually buy an extended warranty on a treatment facility if you want to. It's all contracted, and that starts to get very, very costly at that point, because the systems, they're not going to fail after that 1 year. Typically, the life cycle replacement on a lot of these things is 10 to 15 years. So their chances are they're not going to fail, but it's just about getting through that initial hiccup phase of something. I've seen three-phase motors wired incorrectly, so they're spinning backwards instead of the right way. So I've seen stuff like that, and that's where the warranties really come in. And performance, if it's not meeting performance standards, that's where they come in. So a year is usually long enough to cover all those possibilities.
All right. Thank you very much, Jason.
Mm-hmm.
If there are any further questions, please kick down Jason Bobko's information and feel free to contact him. We'll have his email up at the end of the presentation as well, in case you have any questions you think of later.
Great. Hey, thank you very much, everybody. I was happy to be here today. It was awesome.
Awesome. Thanks, Jason. Okay. So about 5 minutes early, but we're going to go ahead and move on to our next presentation. Presented by Cal Ramon. Cal, are you available?
Yes, I am. Let me see if I can show my presentation. My
Pass the
screen.
screen. Okay.
Okay. Are you seeing the full screen?
Yep, you're good to go. Thanks, Cal.
Okay, wonderful. Thank you, Ebony, for inviting me to present today, and thanks for ADAQ for arranging for this wonderful training session. My name is Cal Raman. I'm with KUV Consultants. We provide services to water and wastewater utilities in Arizona and rest of Southwest on issues related to resiliency, security, emergency preparedness, operational optimization, so on and so forth. And the topic that I'm going to be presenting on is the required record keeping and knowledge retention tools for public water systems. First off, are you able to hear me clearly, Ebony? Am I coming through clear?
You're good to go, Cal.
Okay, great. This topic nicely dovetails with what Jason was talking about the previous presentation, wherein he described the startup processes. You know, how do you get a treatment system going? This takes it to the next level. Once you have the system going, the challenge in our industry is not merely to operate the equipment and produce the product that we do, but also to maintain record of what it is that we do, and also retain the knowledge that goes into how we do things. So documentation is extremely important to our industry, to the water sector, for many reasons that I'll get into. And I want to make a distinction now between the two aspects of this presentation. One is the record keeping. Record, by definition, is the documentation of certain data and facts and documents for future use. And it is static in the sense it cannot be changed. It is whatever happened is recorded and it is documented and it remains unchanged. That is one aspect, and it's a very important aspect of what we do in the water industry. The second component of this presentation is knowledge retention. Knowledge retention, knowledge is relatively fluid. It is not static like data. It has to do with how you run the system and what skills and procedures and knowledge that it takes to run the system. So there are two different aspects, and hopefully I will be able to touch upon them both in this presentation. All right. Okay. What I'm going to do is talk briefly about the benefits of record keeping. What are the records to maintain, and how long should those records be maintained? Those are the three aspects that relate to record keeping. And finally, I'll touch upon certain techniques for retaining knowledge, especially as it comes to running a water system. First, the benefits of record keeping. Many of you running the water system, operating the water system, are fairly familiar with many aspects and the importance of keeping records. It is to ensure regulatory compliance. All said and done, water industry is highly regulated. We have various levels of regulatory agencies looking upon our operation. It could be at a local county level, such as Maricopa County or Pima County that have primacy. It could be ADEQ at a state level. It could be EPA at a federal level. So we have different government agencies looking at what it is that we do, including ACC as on a corporation commission if you're a private utility, right? And for them to ensure that you are doing your part, you're doing your job, they obviously cannot be visiting your facility every time. So they rely on various parameters that you submit to them to make sure that you're doing a proper job. And that protects the customer's interest or the consumer's interest. So the first benefit or requirement for keeping a record is to ensure regulatory compliance. If you don't keep the adequate records, you're in violation and you will be penalized. So right off the bat, it's not a choice. There are certain records that you have to maintain. Going beyond that, beyond regulatory compliance, maintaining documentation of certain kinds of information, certain kinds of data has other benefits to the water system. One, evaluation of process trends and aids in optimization of plant performance. Jason was talking about is the startup procedures, whether it's a startup of a new facility or operation of an existing facility or a water system, you rely on past information, past knowledge, trends such as changes in water quality, perhaps nitrate levels are slowing going up. Maybe you're not in violation yet, but it has been creeping up. So paying attention to that. Maybe the water level in your well is dropping. Perhaps you are seeing a relationship between the TOC, the total organic carbon in your raw water, and the disinfection byproduct level in your finished water. So those kinds of trends can only be done using data, analysis of the data. So you want to make sure that you document those the data and use it as a tool in the future for performance enhancement or optimization. The third aspect of maintaining data is for preventive maintenance. Especially this comes into play when you have particularly an asset management plan. An asset management plan, as many of you know, is a vital tool to ensure the reliability and resilience of your equipment. So it is not sufficient if you perform maintenance on the equipment, but it is important that you document it because people change over a period of time. Equipment the wear and tear on the equipment may also change. So documenting what work was done on the equipment is important to then figure out at some point, are you going to continue to repair this piece of equipment, or is it time to replace the equipment, right? So all that comes into play only when you have a strong set of data and document to back you up. And finally, protects against litigation. This is unfortunately a necessary evil in the industry that you are in, water sector. By virtue of what you do, you provide a product that has health implications. It has economic implications. Any kind of a public notification, such as boil water alert or do not drink, etc., has significant ramification on your community. Or maybe a pipe break could cause infrastructure damage. So you are constantly exposed to the risk of litigation, and to protect yourself against that, you need to have well-documented information, well-documented record of what it is that you have been doing. So for all these reasons, keeping a record of documents is extremely important. And what kind of records should you maintain? There are many kind of records. One, let me start with system information. The drawings, the facility drawings, the as-bills, all those should be well documented, should be saved either in hard copy form or preferably in digitized format and backed up. Map location, the distribution maps showing the pipe locations, valves, hydrants, those are important information. Equipment purchase and repair records, as I said, that relates to your asset management plan that ought to be recorded and documented. And any permits, it could be your discharge permit, it could be your approval of construction or approval to operate. Any of those kinds of permits should be documented, saved, recorded. Operational records, certainly the daily operational logs that you keep, well production, the flows from your well, your booster pump station, tank levels, chlorine levels, all those should be documented. Maintenance log, again, going back to your asset management plan, any repair, any maintenance that you perform on the equipment should be logged. Chemical purchases and customer complaints. Those often are not, but should be, because that helps you diagnose there are certain issues in your water system. They also form a wonderful reference for future use. If you had encountered certain kinds of complaints from certain parts of your distribution system, that lends itself to perhaps certain infrastructure improvement. Maybe there needs to be better looping of the distribution pipes there. Maybe the water is becoming stagnant and hence the taste and odor complaint. So all those kinds of record help to manage your system better. And finally, water quality compliance. This is mostly the compliance part, the regulatory compliance part. If you run a surface water treatment plant, turbidity is something that you track very closely and document it and record it. Disinfection byproducts, disinfection residuals, and of course your monthly, quarterly, annual samples that you are required to do. All that goes into your consumer confidence report and also gets submitted to the primacy agency. Okay, let me talk about how long to keep these records. It depends on the kind of records you're talking about. There are certain legal requirements. At least 3 years, you need to maintain records of any actions taken by your system to correct violation, public notices that your system has issued, such as boil water alert or any kind of tier 1 violation. So up to 3 years, you need to make sure you keep records that relates to what caused it, what corrective actions you took, what kind of public notifications you issued. 5 years, the minimum of 5 years for all microbiological and turbidity analysis, any kind of exceptions that you received for any of the MLCs or any primary contaminants. So microbiology, just 5 years. 10 years for chemical analysis. These are the disinfection byproducts, residuals, nitrates, radionuclides, SOCs, VOCs, IOCs. Those kinds of chemical analysis you are required to maintain for at least 10 years. And any sanitary surveys that were performed, any corrective actions that were taken following the sanitary surveys, right? 10 years. Permanent, as in as long as the system exists. System-related information. These are the as-built drawing, your pipeline drawing, your permits. They will have to be maintained for, well, eternity, or at least as long as the asset is in place. So that's often missing. Many of the water systems, particularly the small water systems that we visit, we find that they lack the as-built drawings or information on many of their assets, or even a good distribution system map. But those are records that have to be maintained and documented. EPA has some guidelines on what kind of records should be maintained. I highly encourage those of you who have not seen this document to download it. You can just Google EPA reference, quick reference guide, and it brings you up this document. And it talks about some of the basic record keeping requirement. I would certainly double check with ADEQ and your primacy agency if it's the county, to see what their specific requirements might be for record keeping. Again, there are record keeping for legal purposes, for compliance purposes, and then there's record keeping for operational enhancement and assistance. Okay, how do we maintain the information? There is this famous management guru, Peter Drucker, who famously said, you cannot manage what you cannot monitor, right? So if you want to manage something, you need to collect the data, you need to monitor it. I think we do a great job of that in our industry. As operators, you all compile a wealth of information, data, almost on a daily basis, be it operational data or water quality or equipment related. So I think we need to go to the next step and come up with our own phrase that goes something like, what doesn't get recorded doesn't exist. Meaning, if something is not documented, it never happened, right? So it's like, the phrase, if you're in, what happens in Las Vegas stays in Las Vegas, and that's good. If I'm visiting Las Vegas, I don't want to document what I do. But if I'm an operator at a treatment plant, I better document everything that I do because I want it to exist. So documentation, meaning writing down or logging it onto the computer in some fashion, capturing that information is extremely important. You cannot rely on memory alone, right? Memory fades, people move, so things have to be written down. Sometimes it's legally required, sometimes it's just the best management practice. And writing it down or logging the information doesn't necessarily have to be a very tedious process, or doesn't have to be a very sophisticated process. It can be as simple as an Excel spreadsheet or a form that you create that you can write on legibly, capturing the information that you need to. So here's a simple maintenance log sheet that talks about what is the equipment that you work on, what's the make, model, serial number, and what specific actions did you take. Documenting that simple task that you probably perform on a weekly basis is extremely important, because it leaves a trail of what has been done to the equipment. And again, this goes back to, at some point, saying, why is the equipment making that noise, or why is it not functioning as it ought to? And if you have a nice record of the work that was done on it, so you can figure out what additional repair it may need. Or you may say, you know what, we have worked on it frequently enough and we are not able to fix it, maybe it's time to replace the equipment. So equipment maintenance log is a simple form that can be used to capture the work that you perform on those equipment. Lab bench log sheets. Again, lab data is some of it provides operational assistance, helps you better understand the process and optimize the process, but oftentimes it is also required for regulatory compliance. So you would compile your daily or weekly data and submit to ADEQ or your county primacy agency on a monthly basis, some of these parameters. So writing them down legibly is extremely important. Any formula that you use should be documented. Again, this may have legal implications, but more importantly, when another operator comes in to take over from you, be it a different day or a different shift, this explains to the operator what it is that you did. So instead of just saying I set the 4-meter or feed pump at 50 mil per minute, how did you come up with the 50 mil per minute? What was the basis for that? A simple calculation, documented calculation would help him or her verify what you did, maybe and make some adjustments. And if you made any mistakes, he or she can catch that. So it's important to document what you did, but also go a little bit more and explain yourself as to what is the reason why you did what you did. All that provides for a nice paper trail. Okay. Operations logbook. Again, any of the operational changes that you made, decisions you made ought to be logged in and written out very legibly. It should be dated. It should be signed. And what is important with many of these record keeping is that record, as I said, by virtue of its definition, is something that is saved for future use. It does not get changed. So you want to be able to, you want to write in black pen or blue ink. Don't use pencil, okay? You don't want any changes to be made. If you have to make any changes, don't use whiteout. You have to cross it out and make the change and put a signature next to it. So think of any of these documents, logs, as potentially legal documents that could come up at some point in future. Not to scare you, but that is the reality. And in certain instances, such as water quality data, it's a legal requirement. So again, don't use pencil, use pen. If you need to make changes, make sure you cross it out, you make the change, and you sign so that it's very clear that you signed, that you made the change, or someone else made it, but you know who it is, right? So extremely important. That's probably the biggest thing I should be emphasizing. These are, consider them as legal documents. Okay. So operational logbook, and then of course those are the simple ways. As we now evolve, we have many water systems that use technology, SCADA, GIS for all your mapping systems, work order systems for equipment maintenance. All of those automatically capture the information and make it available to you for any compliance reporting or for any kind of process evaluation that you may want to undertake. So you have those tools available to you, especially if you're a medium or a large size water system. All right. These are all various ways that you can use to record and document data and information. Now, let me quickly touch upon the second aspect, which is knowledge retention. And I think Jason alluded a little to this when he was talking about the startup procedure. He emphasized the fact that you need to bring operators on board well before you start, before the plan goes online. He talked about the role of SOPs and O&M manuals. All those kinds of tools go into what we call knowledge management, right? The document knowledge by itself is a document of the business processes. These are not data. These are not your turbidity numbers or your disinfection byproduct numbers. These are procedures and skills that are used to get the job done. While every plant may have or should have an operation and maintenance manual, O&M manual, that's only a starting point. Many of you who have been running the systems know very well that a lot of the procedures come through, get refined through practice, right? And there's a lot of institutional knowledge. Experienced operators are very valuable because they have a lot of institutional knowledge that go beyond what O&M manual may show or what your valve or your distribution map may show. They may know exactly where a certain valve is located with respect to a gas station or something like that. Knowledge retention is a process of capturing those kinds of institutional knowledge, especially in this day and age where we have a fair number of the workforce retiring and we have young workforce joining our industry. The documentation of the knowledge is extremely important, right? So this is something that you need to write out either through standard operating procedures, SOPs, operational guidelines, which are more guidance as opposed to structured or prescriptive SOPs, and things such as emergency response plan, your safety plan. All those are part of the knowledge capturing process. The tools that we use to capture knowledge and document it in written form are the SOPs, the emergency plans, so on and so forth. So that's the first step. The first step is to capture the knowledge, right? So oftentimes this is through workshops or having a team of people sit down and write out a procedure on how to handle high turbidity raw water. That could be a procedure. Or how to handle high chlorine residual in the distribution system, or how to respond to a water main break. These are all procedures that you can write out collectively as a team, right? That's step one. Step two is to train your staff. Part of knowledge retention is training. Otherwise, it's just knowledge documentation. You've just written it out. But to truly retain it, you need to provide training to the staff. So if a small number of employees were involved in developing these SOPs or procedures, then have kind of an overview training to all the staff involved on how you would respond to certain kind of situations, right? So a kind of a lecture type of training will be valuable. On top of that, to truly make sure that their employees have understood the procedure, tabletop exercises are wonderful tools. It's kind of a discussion-based, scenario-driven exercise. So you would say, hey, it's 10 o'clock in the morning, and you get notice from the SRP that they're going to be releasing a lot of water into the canal. That could be churning up the water, and we're going to have water with 100 NTU coming into our treatment plant. You have about 3 hours to respond to that. What are the steps that you would take to make sure that we are capable of handling that challenge and making sure our finished water turbidity doesn't exceed 1 NTU or 2 NTU, right? So those are the kind of tabletop exercises. Cross-training is a key component of knowledge retention. Many utilities are now encouraging operators to hold multiple certification. So it is not uncommon for a distribution operator to have his distribution certificate, but also a treatment certificate. It's not uncommon for a water treatment plant operator to also hold a wastewater treatment operator certification. So you have those kinds of resources available within many organizations. So one of the ways to retain the knowledge is to provide cross-training on a regular basis, so that if there is a shortage of employee in a certain area, and we just went through that with COVID, right? COVID was a classic challenge to the continuity of operations plan, where employees were short in supply, and you had to make do with what you had. So cross-training is a key component of knowledge retention. And the third step is important, and it is different from record keeping. In record keeping, you don't go back and mess with the record. It is there. You leave it unchanged. But in knowledge retention, you need to regularly update your SOPs. You have to retrain your staff. This is the way we have always done it in the past, is not a virtue. Okay. So yes, it might have been done a certain way in the last 5 years, but you may now have new equipment, you may have new resources, maybe technology has changed. So unlike record keeping, knowledge retention requires you to go back and revisit the procedures and rewrite the procedures or refine the procedure as may be needed, right? And that's a very important step. So knowledge retention, document the work procedures, train your staff, and update the work, review the work procedures and update them on a regular basis. Okay, that's key to knowledge retention. Okay, we're heading to the end of the presentation. Summary, record keeping is obviously required. You know, if you're in the water industry, you know you are required to keep records for regulatory compliance. But that's not where its purpose stops. It does help, like as we discussed, with process optimization, process management, asset management, and it may be required down the road for any kind of legal issues. Record keeping should include system-related information, operational record, and water quality data. Again, we got that. The duration of keeping this record varies depending on what kind of record. You may want to check with your state or certainly if you're a county primacy agency to make sure that you're maintaining those records for the required time. And of course, ACC, Arizona Corporation Commission, if you are a private utility. It's important when we talk about record keeping to emphasize that these are things that document that cannot be changed with time. Therefore, if it is handwritten, make sure you use ink to document it, blue or black ink. Do not use whiteout. Do not use pencil. If you need to make correction, make sure you cross it out, make the correction, and sign it. Again, think of these as legal documents. Different from that is the knowledge retention, which is documentation of work procedures. It's a three-step process. Document the work procedures, train your staff, and revisit the procedures and refine them, update them on a periodic basis. So both these go together. Both the record keeping and knowledge retention go together to ensure a reliable operation of your water system. And again, adding to Peter Drucker's statement, what cannot be monitored cannot be managed. We will add to that to say that which was not documented and retained never happened. So if you don't have it in writing, it never happened. You can say all you want, but the verbal record of information is oftentimes not reliable and it's not valid. So you need to be able to put it on paper and document it in some fashion. So with that, I will try to answer any questions you may have. And thank you for your attention and for giving me this time.
Thank you very much, Cal. Very insightful. Any questions, please direct them to the question box. Don't see any right now, but if you think of something coming up later on in the hour, please feel free to contact Cal. We'll have his information posted at the end of the webinar. But good feedback from David Richardson, Cal. Okay.
I do apologize. Lesson learned. I went running 5 miles this morning. My throat was extremely dry, so I was gulping down water as I was speaking. So lesson learned. Don't do that before your presentation.
Very nice. Please stay cool out there. This heat is just getting everybody.
Yeah.
All right, perfect. And just to add to that retention, the records keeping, I know personally for me in the field, right in the rain, waterproof paper has saved me in snow and a few ocean trips. So please prepare all of your documents. As Cal said, if it wasn't written, it never happened. All right, so we're just at time for a break. So we're going to go ahead. Let me go ahead and put this up for sharing. Share my screen, which should show the 10 minutes. Perfect. So we're going to go ahead and take a 10-minute break. Go ahead and resume this webinar at 10:10. We'll follow up with electrical basics, wildfire preparations for systems, and close with as-built, understanding construction drawings. So go out, do what you need to do, get your drink of water, take a stretch, and we'll see you in 10. Elijah, are you there? Let's see here. All right.
I was muted. Sorry. Can you hear me now?
I definitely can. No worries. I know it takes a second to navigate the bars
Yeah, and
there.
as soon as I pull up my PowerPoint, that the little help bar disappears. So hopefully it works out. Ebony, are you seeing my presenter screen or the screen you should be seeing?
All right, good morning, everybody. Welcome back. I'm going to take over for a little bit. Elijah, are you back on with us?
Can you hear my audio?
I hear you just fine, yes.
Okay, perfect.
Okay, I'm going to transfer screen to you. Okay, so you can take over and start presenting. Are you ready?
Yes.
All right, you should
And
have people. Yes,
quick question for you, Jason. Are you seeing the presenter's view or the presentation view?
I'm seeing your presentation, sir.
Okay, perfect. We're okay to get started?
Yes, go ahead.
Okay, thank you. So one of the things I wanted to start with was thanking ADEQ for putting on these events to help operators. I'm an operator myself, so getting the PDHs sometimes is hit or miss. But they've been putting on quite a few of them lately, really quite a few. So also want to thank City of Phoenix on whose behalf I'm here today. And they basically facilitated this portion of the training. So some applause for them. Also, they kind of, from what I've noticed, that this is my third presentation with ADEQ, I've noticed that they really hit points that are important or where there's a need in the communities and even specifically doing the training in those communities when they're in person. So this class, or this 45 minutes we have, we're going to cover electrical basics. One of the kind of highlights I noted was preparing operators that are going from the grades 1 and 2 or lower grades to 3 and 4, kind of what to expect. But we're going to cover something basic enough that even guys just starting out can do. Also, back to that previous point, this is really something kind of based on feedback from operators, from what I understand. Some questions about the electrical basics. If there's cross training, there's probably not a lot of electric specific stuff. So just kind of get a primer for everybody as far as electrical questions go. Quick introduction of myself. Unfortunately, you guys can't see me on my screen, only my screen, but example what I look like. Spent time as a plumber working at small wastewater and water facilities, really small facilities. Then became a contractor with the USDA Rural Development, working with small systems specifically, so anything population under 10,000, even populations under 1,000, and did that contracting through National Rural Water Association. Then left in 2019 to start Santa Cruz Solutions. Basically seeing a need for training and work. I'm a contractor for City of Phoenix to do their OPCERT training. So big heavy emphasis on safety also, but a lot of water, wastewater training. I've got backflow certifications through for testing and installation through IAPMO ASSE, an authorized OSHA outreach trainer for general industry and construction. Also have CSHOs for general industry and construction, and just completed the one for healthcare. Through the National Safety Council, conduct training to authorize flagger safety for traffic control and also forklift operators, and then have MESH AZ, Manager of Environmental Safety and Health, for general industry and construction through them. As far as my certifications through ADEQ or EPA, I'm a 4x4 operator, so I've got grade 4s in all 4 of them. But I don't know everything, but I'm really familiar with the test. So I always tell the people in the class when I start my students that if I don't know the answer to something, I won't make it up. I'll find the answer for you, email it to you, that kind of stuff. But really familiar with the test. I also took all my tests together. So I took all my grade 1s within 2 months. Every other grade I did them all together within a month. So the same electrical questions sometimes show up. I may not be able to tell you exactly which test it was on, but I know what kind of questions in certain fields I remember seeing. So I'm familiar with the electrical knowledge. And part of the reason why I brought up all my certifications is to my next point. I'm not an electrician. So it's a huge honor for me to do this class. And again, City of Phoenix asked me to fill in for this. They had some great electricians, and speaking to them, very knowledgeable, but it's kind of a technical point for them. And also not every electrician is going to have water operator certification. So I'm here to kind of bridge the gap between OPCERT questions and general knowledge for the exams and electrical safety and basics of electricity. But again, not an electrician, so this is just my advice, only mine. Course objectives, some things we're going to cover, electrical questions in the ABC exams. Kind of tricky where those questions are, where we're going to find them, where we find information on them. Understanding electricity and the basics, that's going to be a big emphasis for what we're covering today. There's also a theme about how electricity is like water. There's a lot of comparisons that really hold true between the two of them. So I'd like to explain it the best way I can with that in mind, because everyone's got water experience to some degree. So there's a really a tie between the two. Specifically, we're going to be covering voltage, current, and resistance, what the differences are, and then AC and DC circuits. And I have more slides. We won't get into trouble running out of slides. I'm just not sure exactly where we're going to stop. So it's kind of an elusive subject again, and I think it really is just from feedback, ADEQ, requesting this kind of training. So really happy about that. Starting with the OPCERT exams, where we're going to find information for that. ABC cert. Trying to see if I can circle that through my get these command prompts out of the way. So ABC cert is what you normally search for that. The website is abccert.org. This is where you get information on the exams, need to know criteria, study guides, all kinds, and you can kind of see from this outline here. And I'm not sure what the actual details are, but when you go there now, they have a new website, Go WPI. I know WPI is Water Professionals International. So I still call it an ABC exam, but it looks like the name might be changing the organization. So you can still find the information here under testing services, or if you click the new link, it'll take you to the new website. And kind of the same line, if you click on testing services, it'll take you to examination resources in the drop-down menu. If you click that, you can pick need to know criteria. So they also have training information, stuff like that. But the need to know criteria is broken down by grade, by discipline. So 1 through 4 treatment, 1 through 4 wastewater treatment, 1 through 4 distribution, collections, and so on. All the examples I'm going to show you guys basically come from the distribution. So I pulled all 4 of these for distribution, and I'll kind of give you some of the outlines they give you. At the beginning of the need to know criteria, each one of these, they kind of give you these icons and what the icons stand for. So the first section is a light bulb that's green, it's recall. This is kind of what you guys might have been used to when you took your first grade 1s, grade 2s. You didn't have to do a lot of analysis or figuring things out, but you had to remember certain things. So they may ask you how many types of valves are there, how many types of pumps, or a lot of times they ask what's the most common type. So what's the most common type of valve in a distribution system? And you just had to recall things. So this is just recalling and memorizing some of the things in the system. For application, moving up a step, we're basically asking, so which type of pump would you use in this situation? Or which type of valve or pump would be best suited for this particular application? So you may have 4 right answers, but you've got to pick the best, or that kind of thing. And then analysis, now we're past all that, but this is in a higher grade. Your pump is doing this, and this is happening. Here's what the operator is noting, and what's the cause for this. And again, sometimes they may ask what's the most or the least or the first. Big blessing for us on those test questions, it's all caps. So you'll see which is the most, it's all capital letters. Anytime you see that, definitely pause and go back and take note that it's not all the answers. If it's most, they're looking for only one of those answers. So kind of 3 different things we're going to look at: recall, application, and analysis. And starting from recall, it just kind of gets a little more difficult from there. This is from the grade 3 need to know criteria. So anyone who hasn't looked at this before or just starting to take their exams, if I was going to take my grade 3, I can see what kind of questions I'm going to get, and basically broken down into quarters, about 25% each quarter. The first one's going to be distribution system components. The next one is installation, equipment installation, operation, and maintenance. The third one is disinfection, monitoring, evaluation, lab analysis, interpretation. And then the last section is security, safety, administration, procedures, and public interactions. One thing I always like to note for collections and distribution specifically, safety is always about 25% of your test. I think pumps and motors are usually about 25% of your test too. So it's a good place to focus and trying to pick up as many points as you can get. That's mostly because of the trenching and the work involved for those. Once you get into water treatment and wastewater treatment, the safety drops down quite a bit because you're not really in trenches and digging holes and utility excavation, that kind of stuff. Where we're going to find our test questions for electrical, we're definitely going to be looking into equipment installation, operation, and maintenance. That's going to be our pumps and motors, fuses, GFCIs, wiring, that kind of thing. And then you're going to find some of it in safety too. There's always going to be some electrical safety. That's a big part of it. Another thing you'll note with the safety section is that kind of shrinks as you go up the grades for most of the disciplines. But it also changes. So in the very first grades, we're really concerned about the operator hurting themselves. So hard hats, PPE, that kind of stuff. Then once you get grade 3, grade 4, now we're concerned about the public. Now we can start harming people with our treatment potentially. So the same safety section is there, but the focus is a little different. So looking at the difference between these, when you look at all the grades, really what's the difference? We're going to go through distribution 1 through 4 now. So this is distribution grade 1. This is a need to know criteria exam content outline. And specifically in equipment installation, operation, and maintenance, we have 10 questions that are recall. These are just things you have to know the names of. 14 questions about application, which type of valve, which type of pump, which type of motor. And we have no analysis questions. We're not expecting someone, or ADQ is expecting someone taking their grade 1 to be able to analyze problems with a pump. You also notice in all 4 sections here, there's 0 analysis required for any of them. So again, grade 1, we're starting out, don't need much for analysis. Another note I want to make real quick is this section in the circle, these are our math questions. If it's been a while since you took your grade 1s and 2s and you're just now taking 3s and 4s, on the old test, it was pretty random. And I may be wrong, but from what I understand, and from my feedback with students was that we could spend a whole day teaching math to a class, and half those students would get 3 math questions. And then if you're like me, you got all 15 math questions. So people would be upset or happy either way, just depending on how many they got. The guesswork's basically out of it now. So for grade 1, we know for sure there's 8 calculation questions. It may be a really simple question, but we know we're going to get 8 of them. Moving up to grade 2, the math questions have gone up 2 points. And if we look at the equipment installation, operation, and maintenance, recall is the same. We still have 10 questions there. Application is 13, so that's gone up 1. And we now have a analysis question. So now we're asking questions, your bearings are hot. What's the cause for this? Or what's the cause for the pump to be shaking erratically or damaged, that kind of stuff. Maybe 3-phase questions, single-phase questions now. We still have no analysis, not much. We have 1 more in safety. So that's our grade 2. Not too much of a change. Here's the grade 3 outline, the grade 3 distribution. And again, it's basically a quarter each section. So about 25% of your grade falls into one of these 4 sections. When we look at recall, that stayed exactly the same at 10. Application is 12. So we've actually gone down 1, and they took that and added to analysis. So now we have more troubleshooting, more why is this happening? What should the operator do in this situation? So a lot more hands-on experience. Looking at the grade 4, a quick note, we have a lot of analysis questions now. We have 5, 6, 7, 8, 9. We have 14 analysis questions. So at this point, they're expecting the experience to be more hands-on and operational stuff rather than just what you've read in a book or studied for the exam. Looking specifically at equipment installation and operation and maintenance, or O&M, we still have our 10 recall questions. We have 13, still added 1 application question, and analysis is the same, so we still have 2 there. Again, these are the 2 sections we're going to find our electrical questions in. Not so much in any of the other ones. Take a quick look at my notes right here. Okay, if you move on in that same website, when you're looking at the need to know criteria, this is really hit or miss. I know some people love that there's this information here. For me, it's never been really, really helpful. In my mind, it just kind of says you need to know everything. So this is, in this reference, for example, this was a grade 3. I just searched find on page the word electrical or electric, and nothing really came up. But there's definitely electrical questions. So there is a lot of information, but I'm going to show you guys another source that I think is really helpful for that. And you'll have this for reference on video too. When you take your test, it's important to note that you're basically getting that same breakdown. This was, I believe, my grade 2 distribution. And you can see each section. On the right, we see these lines that kind of tell us, where they fall. Wherever they fall, that kind of shows you in this area, you need some work or didn't do so well in that area. And one thing of advice I'd like to give to anyone retaking a test is not to just focus on your number here. If it's not a 70, you didn't pass the test. That's not really the concern. I'd really like everyone to focus on how they did in these areas. Because if I look at one area here, for example, if I hadn't gotten that score, and this is actually really funny for me, my worst score here was perform safety administration. Being an authorized OSHA instructor and has so much background in safety, that's actually the worst score I got on the whole test. But if I needed to retake this test, I would want to focus on that safety section because I got 13 right out of 16 questions. So there's 3 questions I could pick up just by studying safety. So that's one note as far as how we can use this to study for it. But then we'll also see, okay, my pumps and motors questions were definitely here, electrical, that kind of stuff. And so it'll give you how many areas you've mastered, how many areas you didn't master, partially mastered, and kind of give you a breakdown. So it's a really good resource for studying if you're retaking the test, or even for me, I passed the test and now I can look and say, well, these are my worst areas. Where can I pick up points for next time? That kind of thing. Sure where that pen carried over. I can erase it. Nope. We may have this red pen line throughout the whole presentation now. See what I can do about it. A really good resource here, in parentheses, is Water Operator Certification Study Guide. So this is the 6th edition. It's a guide to preparing for water treatment and distribution operator certification exams. It's by John Yorgi, and it's reviewed by the Association of Boards of the ABC certification board. So the kind of tricky here, I don't really recommend this book because I've gotten a lot of feedback from guys taking their exams where they study this book. And if you've never seen this book, when you open it, there's basically about 2,000 questions and answers, and they're test-like questions. So they're asking you about all kinds of different things you will see on the test. But a lot of people study this book thinking, well, if I study this, I'll do well on the exam. The problem is you'll spend 2-3 months staring at 2,000 questions and answers, and then when you take your test, I've never heard of anyone saying they got even 5 of the questions on their test. Maybe 2, 3, 4, that kind of thing. So it is a good study guide if you use it in conjunction with actual information. If you have the Sacramento manuals with you, other manuals where you can look up not so much the what, but the why and how to get more background on those questions. But this book does have a really good breakdown of, again, it's ABC reviewed. I think it's better than ABC's need to know criteria, but it has a good breakdown for that. I'll see if I can rewrite over this. There we go. Erase everything. So looking in the book, again, using that for a reference, the Water Operator Certification Study Guide. This is just distribution and collection and water treatment. I don't think there's anything on the wastewater side in there. We see here on this first kind of outline for operate equipment. So O&M, we're going to kind of break that down into operation and maintenance. We'll look at them separately because they're listed separately here. So looking at operation, we see electrical motors. Now we have here at the top, level 1, level 2, level 3, level 4. So for me, if I was taking any of those 4 tests, I would see, okay, in grade 1, I just need to comprehend and recall. ABC uses the term recall. They basically replace that for comprehension here. So it's not really understanding, just a lot of memorization or understanding somewhat. And then application analysis are the same. So if I look at electrical motors from level 1, it's just comprehension. Level 2 and 3, there's application and then analysis, and then level 4 analysis. And again, the questions just get just a higher number of questions in each one of those fields. Electronic testing equipment's another one. And then not as much, kind of a lighter blue here I made, but blowers, compressors, generators. There may be a question about fuses or breakers, that kind of thing. Looking down directly from the operations section, they break down 2 more sections, knowledge and ability. So for knowledge, we have general electrical principles, and then under ability, demonstrate safe work habits. So remember, we are definitely going to get electrical questions that are safety related, having to do with lockout, tagout's a big one, breakers, fuses, what an operator can and can't do. Again, whether or not they're an electrician, it might change that. But general electrical principles, and that's basically what we're going over today. Another one is recognize unsafe work conditions. So the way you should read this is looking for hazards or recognizing hazards. We want to make sure we can recognize hazards to avoid them. Now moving from operations to maintenance, the M part of O&M, the only thing I really noted here was electric motors, electrical grounding. For example, you may be asked like what color wire is a ground wire, or what is a ground wire used for? More maintenance questions. Looking at the required knowledge, remember the knowledge and trying to think of the name of the other section. We'll look at it in a second though. Here we have general electrical principles, again, pretty straightforward. Also operation and maintenance practices, so our O&M and safety procedures. So those are definitely going to cover something to do with electrical in our test. Looking at the ability after knowledge, we have monitor electrical equipment. So that's a potential question for us too. The last section of the book, or the last section on our exam anyways, is in the book, perform security, safety, and administrative procedures. So remember, when we're talking about safety, sometimes we're asking you, you're a supervisor, what would you do if this happened? Or more public safety, notifications, that kind of stuff. In here in this section on the knowledge, we see general electrical principles again, which is really good because that's really what we're covering today. We've seen general electrical principles highlighted several times, and that's really what it is. So again, something we're definitely covering today, and kind of leads me to the next slide. I got this from an article, Understanding the Basics of Electricity by Thinking of it as Water by Bill Nussi. And it's a pretty neat quote here. We believe that electricity exists because the electric companies keep sending us bills for it, but we cannot figure out how it travels inside wires. The good news is if we understand how water moves through pipe, we can kind of, again, bridge the gap here and have some really good comparisons for them. And that really falls under general electrical principles. So this will really help us with that kind of knowledge base. So we're starting with the basics. We're going to basically skip past, sorry, I found my notes. We're going to skip past the atom, nucleus, protons, electrons, the shells. We're going to kind of skip past the real basics. And now we're just going to discuss like simple terms of electricity. This is an excerpt from Fred Ragsdale's RATS training manual. This PDF is around everywhere, and it used to be a free copy. Not the website's down now, but he passed away a couple of years ago. So, but this is really kind of a rich paragraph here, or two paragraphs with a lot of information on them. And I've read this several times when I was taking my grade 1s, grade 2s, etc. And I remember getting these questions and thinking back, and really you had to memorize. So as an instructor, I could tell you, hey, memorize these things. I'll pull up a highlighter here real quick. And, you know, it's okay. Hydraulic pressure is electrical pressure is measured in volts. The electrical equivalent to friction loss is resistance or ohms. And it's things you can memorize, but we really don't need to do that once we figure out the comparison and how it kind of relates to what we deal with water. So I'll read through it real quick. Electrical terms like watts and volts have counterparts in fluid hydraulics. Voltage is the electrical equivalent to hydraulic pressure. Hydraulic pressure is measured in PSI, and electrical pressure is measured in volts. The electrical equivalent of friction loss is resistance or ohms. Hydraulic flow is measured in gallons per minute, and electrical current flow is measured in amps. Hydraulic horsepower is determined by multiplying flow by pressure. And this section here is basically math formulas that we have. So I know on old tests I've seen where they ask you what is the formula. Now they'd ask you what's the actual number. So you'd have to find the formula and work those out. If we have time, we'll do some formulas today. Not likely though. So good information here, and all of these are potential test questions. I've seen some version of each one of these. How is electrical pressure measured, and they'll have volts, amps, ohms, that kind of stuff. So kind of need to know exactly how this breaks down, what they are. Got my slide here. Electricity is like a water hose, and three terms we're going to cover: voltage, current, and resistance. And we can see a lot of information here, but we're going to break these down one by one. So these are the three most basic components of electricity, and we'll take a look at these one at a time. Starting with voltage. So a definition for voltage, it's like the pressure that pushes water through the hose. It's measured in volts. So it's not the water moving through the hose, but it's the pressure provided. So this would be our pump, something pushing the water through the hose. In this example here, I've got 3 shower heads. Of course, there could be some kind of obstruction, and I know from experience, I've been called out to fix stuff like this where there's just tons of sand and sedimentation in the screens. But voltage is basically the pressure applied to the electricity to get it through the wire. So here would be the pressure applied. It would be our system pressure. Hydraulic pressure is read in PSI, and electrical pressure is measured in volts. So this next slide, we have a voltmeter reading a 9-volt battery, getting 8.9 volts across here. So that's not how much electricity is coming from that battery, but that's how much pressure we have to deliver that electricity. So again, if we look at the water and electric comparison, what we would normally read is pressure in PSI, pounds per square inch on the water side. On the electrical side, that pressure is volts. That's what's kind of pushing our electricity. And again, a kind of a straight up question on the test, how is it measured? And the answer is volts. Next slide we'll look at covers current. We can see from the example up top, it says size of hose. So it's going to have something to do with the size of the pipe, or again, size of wire. So a definition for current, like the diameter of a hose, the wider it is, the more water will flow through it. It's measured in amps, so instead of gallons, that kind of thing. So the size determines how much current can flow through the pipe, circuit, or wire. And we look at these pipes, we can see each one of them can handle a different kind of a flow. So on the pipe side, we're normally talking about water or gallons per minute, but we're not talking about the pressure anymore. That voltage, something we've left behind, now we're talking about the current flowing through it. So quick slide I made, when we measure our current through a pipe, we're measuring in gallons per minute. And when we measure the the current going through a wire, we're measuring in amps. And obviously not the amps we're talking about, but looked a lot better than the symbol for amps. So that's our equivalent, basically water side, electric side, how they compare to each other. And again, kind of a straight up question, how is electrical current measured? And they'll have amps, volts, that kind of stuff. So instead of just memorizing that paragraph and writing those notes down, I think this long description kind of hopefully helps with that. So how many amps can be delivered through a piece of equipment or electronic equipment? Kind of a sample question for us. If we change that to how many gallons per minute can be delivered, we have this good example right in front of us. I know that this larger pipe on the right can deliver more gallons per minute than this smaller pipe over here. So same idea with wire. That's definitely something that comes up on the exams, or an understanding of that. So the bigger the pipe, the more gallons. It's a really close analogy. The only thing we're missing here is distance. Remember, if we have a pipe and it has a rated flow through it, if we double the length of that pipe, then we have more friction loss. If we make it 3 times longer, we have a lot more friction loss. So same thing with wire. So distance is another factor. We look at this example here. We have a 2-inch pipe and a 1-inch pipe. Might think if I go from a 2-inch pipe to a 1-inch pipe, if I was pumping 52 gallons per minute through that pipe, when I cut the size in half, then I'll be half of that. So I would be 26. But over here we see this isn't the exact number, but just an example. It's quite a bit less. There's a lot of restriction. Same idea if I had electric current going through a wire. So the smaller the wire, the less I'm going to be able to deliver through it. And again, the length is also going to be a determining factor for us too. How long this pipe is that we're pumping water through, and how much water or current we can deliver. So we have our voltage. Our voltage is on that pressure side. Let's assume we're running this direction. What we're really talking about here is the current moving through it. Now we talked about the current moving through the pipe, and we know that the current measured going through here is measured in amps. So that's definitely something we're going to want to know. Remember the picture of the amplifier there. Another really good example that I'd like everyone to kind of visualize is when we think of current, it's literally just like a current of a stream or a river. So the pressure applied here is applied through gravity or some other force pressurizing this water. That's our voltage somewhere back in the background. But this is our current. This is how much water is moving through the pipes, or in our example for electrical basics, this is how much current is moving through our wires or through a circuit. So the voltage has nothing to do with the current in the way that it's not moving. The only thing that's moving here is our current. Our voltage isn't moving. That's just the pressure that's applied to it. Same as our pumps aren't moving. They're applying the pressure to move our water through our pipe, but they're not actually moving through the pipe. So the current is basically like flow of water. And again, I hope it doesn't sound too simple. This is kind of how I picked up my understanding of it, just for the basics understanding. And then it goes, it's a whole rabbit hole from there. So again, with the water moving through our pipe, the size, diameter of the pipe is going to be a determining factor for us. On the electrical side, how much current can move through these wires is going to depend on the size of the wire, the length of the wires, that kind of thing. So that's going to determine how many amps we can deliver to a piece of equipment, to a system. But instead of gallons per minute, we're delivering amps. I've got a quick, I think it's only 2-3 minutes, it's got more technical definitions of voltage and current. This is a video from Magtech Inc. They sell some equipment, but a really good kind of definition. So again, like a 2-minute video, just kind of covering the difference again, just so we're really clear on the difference between voltage and current. A little too technical for what we need, but I think it'll help us.
An electrical current is defined as the number of electrons passing a given point in a second. And voltage is defined as the difference in electrical potential energy per unit of charge between 2 points. To explain this further, let's say we have a body of water, with a pump drawing the water up to an elevated tank. Right now, the water tower has a lot of potential energy to do work, but it isn't yet releasing that energy. So now let's connect another pipe to the tank to complete the circuit and produce a current. In this example, the flow of water through the pipes can be thought of as the current, and the total stored potential energy of the water in the elevated tank can be thought of as the voltage. If we made the pipe larger, the potential energy, or our voltage comparison, would remain the same, while the current would increase. And if we remove the second pipe altogether, there would no longer be a current, but the potential energy, or voltage, would again remain the same, in the same way that a battery has a voltage associated with it, even if it's not currently connected to a circuit or doing any work. Now, in the original definition, we also said that the voltage was the difference in electrical potential energy per unit of charge between 2 points. So back in the example, when we were talking about the potential energy, what we're really referencing is the force of gravity pulling the water from point A to point B. The potential energy, which again can be thought of as voltage, would rise if we increase the difference between the 2 points. Voltage is always in reference to a difference between 2 points. Even when we're talking about a 9-volt battery, what we're really saying is the difference between the 2 terminals is 9 volts. With electricity, rather than in the previous example where gravity was the applied force, it's instead the electromagnetic force. The electromagnetic force is the repulsive or attractive force between electrically charged particles, and in the realm of electromagnetism, opposites attract and similarly charged particles repel. If we take a conductive metal wire and complete the circuit with a battery, the electrons from the negatively charged side of the battery will be attracted to the positively charged end of the battery at a force equal to 1.5 volts in this example. Without voltage, the electrons will move randomly in all directions. Voltage is what pushes electrons around a circuit. So to summarize, current is simply a measurement of the flow of electrons passing a certain point. And voltage is the electrical potential difference between 2 points and is the driving force within a circuit.
Hope the volume was okay for you guys. But again, a really good example of that water tower. I started building PowerPoint slides for that, but that's just a really quick example of it. So rather than just kind of talking over that, let that run through. So we think of that water in the water tower as voltage. That's how much pressure. Again, we know feet of water equals PSI in pressure. How many feet of water we build in head will give us so many PSI. So every foot's 0.433 PSI, but the higher we build that water tower, the more voltage there is. But if that pipe isn't big enough, then we don't have enough we're not able to deliver the current. So from a safety perspective, you'll hear things like 10,000 watts, 20,000 or 20,000 volts. Um, that's not really dangerous as much as the amps are. Remember, it's amps that kill, not the voltage. But that high number is a warning to me that there's a potential for those amps to be delivered. So if those amps are delivered to me, that's the pressure that's behind them. What I'm really afraid of is amps, but the voltage is what's delivering it. So again, if we don't have the correct wiring, we don't have the correct pipe, we're not going to be delivering that energy, that kinetic energy. And I think I was going to draw an example of that here. Looking at the last term, resistance. So we had the shower head. I brought that back for our slide. In the first slide, we were talking about the pressure delivering the water. So in these examples, we can see there's different PSI, but there could also be some kind of restriction in our piping or a clogged strainer, that kind of thing, that would basically keep us from delivering the water to the customer or delivering our current in the form of amps to our customer. So we've covered voltage and pressure. Now we're going to take a look at just amps. Resistance here is like sand in the hose. So we see that picture up top with sand in it. It's going to slow down the water flow, and it's measured in ohms. Instead of ohms, you usually see the symbol for ohms or R, but that's what we're looking for. And again, another question. This, if you've taken the grades 1 and 2s, that kind of stuff, even on the 3, you've gotten a question about how to measure this. A good example of how we can have resistance in pipe. So we talk a lot in water about the C factor, or coefficient of friction. And that's basically the measure of the roughness of the inside of the pipe. So one of these pipes is going to have a higher C factor than the other. And then also over time, since we have a metallic pipe here, we have tuberculation forming on this right side. So this is going to restrict our flow. We're going to have a higher flow through here. So that could be degradation of lines, the circuit, the wires. Same kind of idea happens in the electrical system, but I think this is just a really good example of that. So that could be what's not giving us enough pressure at the end, or delivering enough of the current. You guys will have a lot of math questions on your exams with feet of water, head loss, and also feet and PSI of water. So we know that the higher we take this water, the more pressure there is for the water to be delivered to this pump, since we have a positive suction scenario here. The water source is above the center line of the pump. But I can calculate that. So if I'm looking at a gauge here and I have the PSI, I know that for every 1 PSI is equivalent to 2.31 feet of water. I can take this number times 2.31 and I'll know exactly how many feet of water in this tank, what the level is. But the problem is we don't always get that exact number. So one kind of question they'll ask you on the test is how much head loss is there, or friction loss. So there could be an obstruction. Anytime we have an elbow, a bend, a T, some kind of pipe fitting, a valve, we're going to have some kind of friction loss as that water moves through that pipe. There's no longer a wide opening, and now it has to change direction, or it has to move or be restricted by a smaller size. So same kind of idea. Think of this as an electrical circuit. So we'll look at wiring examples in a second. But there might be some restriction here that gives me a lower PSI than what's expected. And I'll have to figure out what that number is through math. They never tell you what the friction loss is. You always have to figure out what the friction loss is. But it's going to be from some kind of restriction. I know flushing hydrants is a really good way to check friction loss in a distribution system, because you can note you're supposed to be, basically doing that test once a year. And if we see over time that a certain section has more friction loss, then if we have money to replace piping and do repairs, we're going to kind of head our money in that direction, because that's where we have the most tuberculation or pipe failures or something like that happening. I have a personal experience example of this for wire. I was a licensed contractor for flooring and painting for about 20 years. Seemed like a couple lifetimes ago now, but sorry, when I was like 20 or so. And I remember one time I was working on a custom home and it didn't have power. The builder there was lending me his generator. They didn't have the generator one day. But the house next door was completed and they had electricity. So I went to Home Depot, bought myself a big giant extension cord like this. By giant, I mean long, not thick enough. I don't remember if I put one or two of these together, but basically I was doing my cuts on my wet saw at the house next door, and everything was going fine. Eventually came back to turn my saw on, and the motor was gone. I completely, cooked my motor. I didn't understand why, but basically, we're going to cover that now. But I didn't have a thick enough wire to deliver the current needed here. Even though I have a 15 amp breaker, 20 amp breaker, if this saw is only 10 amps on startup, there's a surge of higher than that, so maybe 14, 15 amps. And that's how I destroyed my wet saw. Had to go, buy another one. Now I only use thicker wires for everything. It doesn't matter if I'm plugging in a phone charger. I'm using 10 gauge wire for every extension cord. Same kind of idea with pipe restriction. So here we see, I'm guessing P here stands for pipe. Then we have voltage and amperage. If we have some kind of restriction in our delivery, either through a pipe delivering water or electrical circuit or a wire delivering current, that's going to cause a problem for us. And I found a bunch of examples like this on here. We still have our pressure, our voltage is still there trying to deliver the current that's measured in amps, but we have a restriction here. So this is our pipe that's too small. This is a wire that's too thin or maybe too long, and we can't get what we need to the customer and deliver those amps. So a great visual example there. So looking at these two wires, I'm going to show you guys two sets of wires. Which of these wires has more resistance? So the wires are the exact same diameter. The cross dimensions of both of them have the same diameter, so the surface area is the same. And these electrons passing through are going to have collisions and lower and resistance. The shorter the wire is, the less distance we have to push that. Remember, we have our voltage providing pressure. The shorter the wire is, the less resistance. So our current coming through will be delivered more properly. And then this example here on the bottom is that giant extension cord I thought I was smart by buying. It was way too thin and way too long to deliver the current that I needed. So again, the voltage is only supplying the pressure, not moving through. It's the current that we're concerned about. Another example here, and this is another familiar test question for some of you. Basically, the question is, how do you, which wire would have, if there's too much resistance, what should you do with the wiring? Two of the answers are larger wire, smaller wire, and then two miscellaneous answers. But the larger our surface area is here, the cross section of it, we can also deliver more current. So think of a river. If you have a little tiny stream, you're only going to be able to push so much water through that or a small pipe. Really wide river, if a lot of current shows up, it's going to be delivered pretty quickly because a lot of less obstructions, even if it rises and lowers in height. Same with our pipe, same with our wires or circuits. So the larger diameter wires can deliver more amps. So we've covered it. I think, honestly, if you look back at this, we've covered about 4 or 5 questions already that are just kind of basic general principles about electricity. Quick look at wiring. If I had used a 10 amp or a 10 gauge wire extension cord for my, I may have been too far away still. So this kind of changes. A quick example here, I know my house wiring coming in is number 2, but I could get away with number 6, but that depends on how far away it is. There's basically a rule for this, how many amps are being delivered, how many amps are being used, and then what the distance is. The longer run of wire we use, the higher we have to go, or the thicker we have to go in diameter. What I was using for my wet saw was probably 14, 16 gauge. And here we see 10 amps, which you would think is really good, but then we have those surge amps. So I was probably drawing 13 amps every time I turned it on, 14 amps on startup. So the least resistance of these wires, the wire here that will offer the least resistance for current is going to be our number 2. If I had done that, that would be the same as delivering more water, more power to my wet saw that I was using. Sometimes we want to restrict the resistance. So on a circuit board here, we see these little, we see capacitors, resistors. I'm actually not even sure if these are resistors specifically, but sometimes we do it on purpose where we don't want all the electricity going through some component. So these restrictors here are set to different levels of how many amps they'll deliver to a certain area. So sometimes we want to restrict that flow. We have a set amount of resistance that's built into these, basically to protect. And they're kind of like a fuse that would go bad on us if we were trying to deliver more than that. On the water side, if this was a classroom setting, I'd be asking, what do we have on the water side that's an equivalent to this? So on the water side, when we have a pressure that's too high, a voltage that's really high, and we have too much current moving through the pipes, we can use something like a pressure reducing valve. So this would be an example of a reducer for a resistor for us, where we have a really high pressure, and just a real dumb example, we want to deliver a lower pressure, maybe for just one building, or maybe one part of the distribution system, or maybe a whole section of the distribution system. So that's kind of equivalent of a resistor. What's important is how that resistance is measured. So the next thing we'll look at is reading ohms or ohm meter. This is an example of testing a fuse. This fuse has a wire going through it that the current passes through. If we pass too high a current through here, it'll break that fuse, and the fuse will melt, and that's what's protecting our equipment downstream of that power. So to see if the fuse is broken or still intact, we're basically running continuity tests with a voltmeter here. I'll show you guys the ohm symbol, but we can't see it here, but the ohm symbol is what this is set on, down here somewhere. And basically, we have some kind of reading here on the voltmeter that's telling us there is continuity. That's how many ohms are basically traveling through the wire. In this next example, I've got one where a fuse is being tested, and we see zeros on the voltmeter. That means our fuse is broken somewhere. There's not continuity. There's nothing reading back through. So we have an open circuit now, not a closed circuit. With that closed circuit in the previous slide, we have power going through in a general sense, and we're getting some kind of reading. And here we don't. So again, that's measured in ohms. So that's where that meter will be set to. Going back to the water operator handbook I showed in the very beginning, example question I pulled from there. Which basic electrical unit is used to measure a material's opposition to the flow of electricity? So we are talking about, well, if we kind of go through here, one thing I like to do is throw out some questions. We know that volts are the pressure that supplies pressure for the amps that are delivered. We know what's delivered are the amps, and we're talking specifically about resistance or impedance. But here we're not talking about the electrical unit. Our question is, what's the basic electrical unit? And resistance isn't our unit. How is our resistance measured? Ohms. So that's another example. We would use an ohm meter or mega ohm meter. And then in pumps and motors, we get a little more specific there too. Not sure how I'm doing. Yeah.
Hi, it's Jason. Hey, listen, I just wanted to let you know you're at time, but could you wrap up in maybe 2 or 3 minutes?
Yeah, definitely.
Great, thank you.
Perfect. Yeah, the last section is another term we're familiar with, AC and DC. So it's not just a rock band, it's something we have to be a little familiar with on the test. Not a whole lot, but we'll go over this terms, and we'll cover DC first. We'll cover the opposite order as they're shown here. So alternating current versus direct current. Going to give definitions here for direct current. We'll kind of focus on this section first. It's a constant current flow. So anytime we've used batteries in our lives, a 9-volt battery, a watch battery, a AAA battery, it always provides a direct current. Now we know that's going to die over time. It's not consistent, but as a snapshot, if we look at it at that minute, it's a direct current. It's not alternating. It's a direct current giving us exactly what that voltage and current is gonna deliver for us. A good example of that, going back to that previous video, in this water tower, there's a built-in set of pressure, PSI, delivering that current. So the voltage and the current is pretty constant. There's not really a valve or anything alternating here. This is an example of DC. This is our water equivalent of it. On the electrical side, that would be a 9-volt battery. It's a DC current. It's not alternating. It's providing that current to us. So really good kind of examples, one for one here. Looking at AC current, now we have alternating current. So if we think of like a wall outlet, the current that comes from that through that wall outlet isn't just coming in one direction. It's flowing back and forth. The frequency of that, what it's flowing through here, when we see this, is determined by the hertz. For us, for the most part, that's 60 hertz, or 60 times a second. So this is kind of like a distribution system too. So think of the water flowing through here. I think I've got a picture coming up. So the electricity flowing through here is also flowing back. This is an alternating current. It's moving all through our house, just like a distribution system. At any time of the day, if there's a fire being fought over here where the hydrant's at, all our water is going to flow towards that direction. If there's someone using a lot of water, the water will flow in that direction. The water is always going to find the path of least resistance, so it's an alternating current. That water can go any kind of direction depending on the system. So again, we're fighting a fire here. We'll have water moving from different directions, all moving to kind of help fight that fire. If we look at this picture, I really like this analogy here. If we look at this picture for a second, as it turns into a circuit board, same kind of idea, a lot of familiarity here. So I think of the circuit board kind of like how the power is being supplied to all these little components. There are some components that use AC and DC. So a washing machine is a good example. It uses a combination of AC. So it'll use AC for the induction motor that spins the tub with the clothes in it. But the circuit board that's controlling the temperature, the speed, the timer, all those kinds of things, the lights, that's using DC power. So we can convert DC power to AC power, and we can convert AC power to DC power. So what the washing machine's using to convert AC to DC power is called a rectifier. And if we convert DC power to AC power, it's called an inverter. Another sample question, I'll kind of speed this up. Which device changes alternating current to direct current by allowing the electrical current to flow in one direction, but blocking flow in the opposite direction? So for that last one, again, we don't have a classroom setting, so it's a rectifier. And a good way to think of that is our houses need AC current. So if we think of the sun as a DC battery, it's applying direct current to those, or even more so with the batteries here where the energy stored is DC. We have an inverter. So every solar system has an inverter to turn that DC current into AC current. And the opposite, if we were turning AC current to DC current, would be a rectifier. If you remember that solar systems are directly charged by the sun and have inverters, that kind of gets you past all those questions, I think. I always try to think of dumb ways to memorize things. And the last thing I want to show is our water equivalent of this. The way we convert from AC to DC, we showed the distribution system earlier where water will flow all different directions throughout the day as a normal, thing. What would we install if we wanted the water to flow in one direction only? So again, without the classroom setting here, the answer is a check valve. So this check valve would allow our water to come through here. If water reversed flow and came back, our door would basically snap shut and it would keep it flowing in one direction only. So another equivalent between water and electricity. What we'd use on the electric side would be a rectifier or an inverter, depending on what we were doing. Here it's going to be a check valve. I think the rest were just kind of quick summaries. Real quick for the test, definitely remember lockout tagout is a huge part of electrical safety. As operators, we're allowed to check fuses or reset fuses, but we're not allowed to reach our hands in there. There's been answers in the past like use a piece of wood to wedge the fuse open so it won't snap again, or use a bigger circuit breaker, that kind of stuff. Anytime it's a question like that, remember we're going to contact a qualified electrician. They don't want us to be in this kind of situation. We teach electrical safety, not electrical hands-on. So the difference between an electrician and water operator is we're not doing this, we're calling this guy. So that would be our qualified electrician to handle those issues. So hopefully that helps. I do have more slides. I wasn't sure if we'd go short on time or not. My email address is here. Again, a huge thank you to City of Phoenix and IDRC for facilitating this. And I don't know if we have time for questions or if I even know the answers to the questions, but let me know, Jason.
That's all right. Thank you, Elijah. Yeah, I don't see any in the chat, but I'm sure if we do get some, we will certainly answer those questions. And the other question was, will your presentation be available for download? It's not in our handouts, but if you get it to Ebony, I'm sure we can give them out to whoever requested, okay?
Okay, sounds good. Thanks again.
Thank you. Thank you.
Have a great day, everyone.
Up next, we have Bailey McDade. Bailey McDade is a compliance assistance coordinator here at the agency. So I'm going to go ahead and ask Bailey to start presenting. All right, good morning, Bailey. Can you hear me?
I can hear you. Yes, thank you.
Okay, you're coming through loud and clear, so you're all set.
Perfect. Let me just pull up my presentation for you. All right. Are you seeing the right screen?
I am. Thank you.
All right. Perfect. Well, thank you everybody for coming today. I'm going to be speaking on wildfire preparedness and some discussion on response and recovery as well for public water systems. This is going to be mostly about personnel working at public water systems. As Jason mentioned, my name is Bailey McDade. I work as a compliance assistance coordinator in our drinking water monitoring and protection unit. I was asked to give this presentation because it's a topic I'm pretty passionate about. Before I got into environmental science, I had a career with the U.S. Forest Service as a wildland firefighter, so this is a topic that is near and dear to my heart. I'm also working in improving our agency's response to emergency situations, including wildfires. So I will be plugging at the end of this. I am very eager to get any input, comments, questions emailed to me, especially if you have ever had any experience with a wildfire or other emergency impacting a public water system that you work on. So thank you. Without further ado, I will go through. All right, so just a brief overview. I'm going to be framing most of this presentation through the 4 phases of emergency management. This is something that FEMA uses. Various emergency response agencies have something similar to this, but I'll be framing things in terms of what you can do for preparedness, response, or sort of during the emergency, recovery, or after the emergency, and then mitigation. I've also heard this referred to as prevention, but sometimes there's things you can do to mitigate the risks or hazards, and then sort of separate that out from how to just prepare for things that you have less control over. All right, so real quickly, I could probably go through this for quite a while, but I thought I'd provide some context with some fire or emergency terminology, just to help out, and some things that you might see when you're looking up status updates of wildfires or other emergencies near your water system. So first and foremost, incidents or wildfires are initially referred to as incidents. This is because they use the same incident management system as other environmental emergencies, other security emergencies, things like that. And the way that the system works is incidents or fires are categorized from type 5 being the least complex up to type 1 being the most complex. So a type 5 fire is going to be typically less than about 10 personnel, very few values at risk, structures, other complications, things like that. And they're typically taken care of in one operational period or one day. Type 4 tends to get a little bit larger, a little bit more complex, and might spill over into a couple of operational periods. And then once you get to 3, 2, and 1, that's where you're going to have more resources assigned, likely some communities at risk or other structures, things that make it more complex. You might have air support, and these are going to be fires that could go on for days, weeks, or even months. So the types are not necessarily correlated to the size of the fire, they're correlated to the complexity. So if you are concerned about a wildfire in your area and you see that it is a type 5 or 4, that threat has likely already passed. But the 3, 2, and 1s, that's where you're likely going to have some ongoing impacts and things that you need to check on. So the incident commander, that is going to be the person assigned to managing all of the personnel in the fire. The incident commanders are qualified by type. So you could have a type 5 qualified incident commander up to a type 1 qualified incident commander. And I should mention that fires will move up and down these types as they get more complex and then as they wind back down and are mostly contained. The incident commander is probably not going to be somebody that will be a good resource of information on these larger fires. They're concerned with operations. But somebody you might be able to reach out to for information would be a public information officer. So the PIO is typically assigned to these more complex fires, type 3 and above, smaller incidents or ones that are more quickly resolved. They might just assign somebody at the local Forest Service or BLM office to be that PIO. But that's who's updating the website and the information daily. That's whose phone number or email is going to be available for questions about that specific incident or fire. So that's going to be a really good resource for public water systems. PSPS, some of you might have experienced this, especially up in timber country or areas that are more prone to frequent wildfires or storms. But this is a public safety power shutoff. Sometimes before a large storm, power might be shut off preemptively in case power lines are suspected to be damaged by the storm and potentially either start fires or cause other safety concerns. So sometimes you might be notified of a power shutoff, happening on purpose before an incident occurs. So if you hear PSPS or public safety power shutoff, that's what's coming. Burned area emergency response, they call this BEAR or the BEAR team. So if you hear of BEAR work or a BEAR team coming out to your area, that is after a fire. They're concerned with immediate rehab, burned area restoration, things like putting hay or seed down on steep slopes to try to slow down erosion, looking at stream health, things like that. So that's sort of a triaged first response after a fire has gone through an area. The simplest, most important resource I could probably direct you to is incweb.nwcg.gov. That stands for Incident Web. That is where public information officers and other fire staff update the public on what's going on with that fire or incident. You can also see it's a map laid over some GIS layers. So you can get all your information there and link to if there's a PIO assigned to that fire and updates, usually daily. ADEQ also has some maps that we use internally that have layers for current wildfires and where our community water systems are, at least. Working on expanding that to be more fully integrated. But definitely reach out to a compliance assistance coordinator if you're associated with a public water system and you have a concern or question about whether or not a wildfire might be overlapping with your service area. We can check that and provide some guidance. So just a quick picture. This is what a wildfire briefing looks like. They all look a little bit different, but mostly a little bit the same. You can see there's a few groups gathered at different divisions. So this is likely a type 3, 2, or 1 fire. You can see some, looks like food trucks in the background and some other resources. But just to give you some context, this is the type of briefing that would occur every morning on a fire for as long as it's going on. And they are in-person briefings for operations and for information. So the public information officer is getting their information once a day in the morning from these briefings and then updating the website from there. So if you've got some questions that are getting very specific, these are not open to the public briefings, but this is where they get their daily information. So just if you're wanting more information or more detailed information, then it's something that you can put in a request for and you might have it by the next morning at a briefing. All right, so just an overview. I promise most of my presentation is picture slides, but I did have to put in a couple of these wordy slides. I just wanted to go over, there's kind of 3 main players in an emergency, and that's going to be the public water systems personnel themselves, the emergency responders, and then ADEQ. The public water systems and operators, your main roles and responsibilities are going to be having and following your emergency operations plans or your standard plans for your specific system, maintaining safe drinking water for your customers. You can't always help if there's an outage, but if there's a safety concern of the water quality, it is your responsibility to make sure that you're not serving unsafe water to your customers, and that you're notifying ADEQ of outages, contamination, other emergencies. Make sure that you're notifying ADEQ as soon as possible and staying in constant communication to the extent required or possible, and issuing public notices. Emergency responders are supposed to do just that, respond to the emergency. They prioritize protecting human lives first and then property, and providing status updates through their online resources, public information officers, etc. ADEQ is going to be mainly a guidance role. We'll provide guidance on notification requirements. We've got some templates. We also have templates for emergency operations plans. We can assist with reviewing those, provide guidance on post-fire inspections, including physical inspections of the system, water testing for contamination, things like that. We have a water emergency team we can mobilize to help with additional resources needed, and things like that. All right, so emergency operations plans. They are required of all community water systems. If you work at a water system that is not a community water system, we still highly recommend that you have an emergency operations plan. We can provide those templates, and they're going to be really helpful. Larger systems that serve over 3,300 people also have to have an emergency response plan, which is essentially an emergency operations plan beefed up with a couple of other components, including things like a vulnerability assessment. So not only saying what you will do in an emergency, but assessing your risk level for encountering some of those emergencies. Some basic things that you're going to be required. I'm not going to really dive into this, but it's how to respond to the loss of your source, major component failures, damage to your equipment or loss of power, contamination from various causes, collapse of structures, breaks in your lines, things like that. So this is going to be an all hazards emergency operations plan, but I highlighted a few because you're going to see some overlap with wildfire. Regardless of the cause, the results being damage or loss of power or contamination, you're going to want to follow your emergency operation plan. All right, so in the background here is a picture that somebody with a better iPhone than I have took of Missoula, Montana, and this is the Lolo Peak fire a few years ago. And you can see that, most of this presentation is going to focus on wildfires, but you can just see how close to the city the fires really can get, and how that can really impact drinking water, even if the fire is not physically getting into the city itself. So the main hazards that we're going to talk about, this is not all of the hazards, but I picked out a few that I've experienced or think are important to know as an operator. So it's going to be number one, human safety and danger to personnel, physical damage to the infrastructure, power outages, contamination or depletion of the source, contamination of the water supply within the distribution system, and then some more long-term effects like post-fire flooding and erosion. So first things first, danger to personnel. We do have all of the counties have adopted in Arizona the Emergency Information Network. This is something that the sheriff's departments will typically give evacuation notices in stages. So ready, set, and go. Ready essentially means that you should have dust off your emergency operations plan, make notifications, have a go kit, and be ready to evacuate if things escalate. Set is really, have your go bag in your car, be ready to go at a moment's notice. You should definitely be contacting ADEQ at this point and making plans for what's going to happen at the water system if personnel have to evacuate. And then go is evacuate immediately. So you can go, I linked it at the bottom of this, and these slides will be available. But you can check your county specifically and see if there is an option to sign up for these automatic alerts to be sent to your phone or email or both. So make sure that you're keeping an eye on evacuation notices. Another thing to consider is that just because there's no evacuation notice for the area that the water system itself is located in, doesn't mean that personnel will be able to commute to work. They might have an evacuation notice in their home community, or there might be road closures or other reasons that operators and personnel are unable to reach the plant. Make sure that your emergency operations plan includes these contingencies. All right, so as promised, the 4 phases of emergency response. I'm going to say the kind of biggest takeaways for preparation. Make sure that you're registering for any automatic alerts for evacuation notices you can get. Check INCWeb, that NWCG website, to see new and active wildfires. Check the news, check evacuation orders, things like that. In response, please follow evacuation orders and follow your emergency operations plan or response plan. Also alert ADEQ of any evacuations or operations interruptions as soon as possible. And understand that if you are in go immediately in an emergency response, that notification to ADEQ might come a little bit later, but the earlier you can let us know what's going on, the earlier we can provide resources for help. In recovery, only return to the water system once it's deemed safe to return by emergency personnel, and make sure you're aware of hazardous conditions afterwards. There might be loose rocks, smoldering material, holes, things like that, other hazardous conditions at the site, especially if the wildfire actually did come through your system. And then for mitigation or prevention, I would recommend conducting regular training on your emergency operations plans. Conduct some mock exercises and make sure that it is, just muscle memory at that point. Proper preparation. It's going to feel like just an automatic response if an emergency does arise. All right, so next up is going to be damage to infrastructure. This is also going to be a human safety thing. Defensible space could make a big difference in, the need to evacuate and the ability to evacuate. So just a little bit more fire terminology to put this into context. When firefighters are looking at structures as far as protection needs and defensible space, they use a few different terms. 3 of the terms they might use are standalone, which means the structure does not need additional protection. A wildfire is not likely to make its way up to the structure to cause damage, and so not much is needed to do that. Prep and leave is going to be the structure might need some preparation done, so trimming vegetation around it, setting up sprinklers, other things that would help protect an otherwise vulnerable structure, but it might not be safe for fire personnel to stay at that structure, or they might simply not have enough resources to leave behind firefighters to be actively protecting that structure. So they're going to prep it and then leave. They can't stay if there's not a safe escape route. So that's got to be a priority. And then prep and hold is going to be the same thing, providing some preparations and then staying at the site. More critical infrastructure where there is a safety zone or escape route, they might be able to stay, especially if it's deemed necessary for the protection of the structure. Make sure you're creating and maintaining that defensible space around your structure, which means fire could come through the area and it is less likely to make its way to the buildings and infrastructure that you're looking to protect. So, keeping vegetation down, considering fireproof materials, mowing down tall grass or having, non-flammable materials, parking lots, rocks, things like that around the structures themselves. Here's a couple fun pictures. On the left, this is called a pumpkin, affectionately referred to, I think, informally, but it is essentially a big plastic bag that can be set up outside of a structure and filled with a couple thousand gallons of water if there's no running water at the structure. And then a pump can be set up next to it to work a sprinkler system around a structure if need be. So that's something that might be used if there's no running water. On the right, this is probably not going to be used except for really historic structures. This was a old historic cabin in a national forest out in California, and it was an old log cabin, and it was deemed very important to protect. So this is pretty labor intensive to foil wrap an entire building, but it is pretty effective. And that combined with some sprinklers set up around it, the cabin was not damaged by the fire. So just some options and things that you might see in structure protection. Just one more picture to kind of drive it home. You can see, looks like the house up top had a pretty green lawn around it, a break from flammable vegetation far from the house, so the fire skirted right around it. You can see kind of down in this bottom center, it looks like maybe a barn or garage outbuilding type. Looks like the fire did not stop before reaching it. Probably had, you know, dry vegetation right up to it, and the fire was able to go right through. So you can kind of see the difference between the two. So main takeaways for infrastructure damage in preparation, have that in your emergency operations plan. Take an inventory, including photos. Having those before photos is going to be really helpful if you end up having damage, and then you have a comparison between before and after. And make a stockpile of spare parts if you can, if there's things that are critical to the operations of your water system, and you can stock those spare parts before an emergency. It might be a lot easier than trying to get them after an emergency. In response, follow all evacuation orders, and protect your structures as you're able to, but really let the emergency personnel take care of the structure protection. If you actually have a fire coming through your system, you're going to receive an evacuation order. You're not going to be asked to stay and protect your own structure, likely. Alert ADEQ of any evacuation or any outages, outages that happen after the fire from damages as well. And then in recovery, assess, report, repair those damages, test the water quality. Certainly if you have a loss of power or pressure, you're going to want to be testing for total coliforms and E. coli at the bare minimum. And reach out to ADEQ for assistance with inspections and guidance on testing. And then for mitigation or prevention, maintain that defensible space. You can always reach out to your local Forest Service office or potentially your local fire department to ask them to come out and take a look at your space and let you know what they think about its defensibility. And then consider switching to fire tolerant materials, metal versus wood and things like that. All right, so power outages. Power lines can be a hazard in a few different ways. They can be a hazard to firefighter safety and public safety. They can lead to additional fire ignition from electricity arcing, and fire can also damage the lines, which can then cause all those other hazards. So I will say this is a pretty big one. Working under power lines can be pretty dangerous for firefighters. Sometimes on initial attack or the initial response to a wildfire, the incident commander will make the call to have the power shut off temporarily so that firefighters can work safely around the power lines. They can also make that call. Power companies can make the call to turn off the power in order to protect the lines so that they're not charged while the fire is around them. It can also be, a public safety concern with these power lines. So here I wanted to show some pictures because it's, pretty obvious that if you've got maybe a wooden power line pole or direct flame contact on the power lines, that the lines themselves or components on them could be damaged and fall, and then, be a hazard to the people working around them, and they could also ignite additional fires. But what if there's no flames? Heat and smoke, heavy in the air around power lines, can actually also lead to arcing of electricity. I've personally been on a fire where a lot of smoke and heat did lead to a power line arc on a line that had not been turned off. And that arc made its way to somebody's tool, somebody's metal hand tool that they were working on, and electrocuted the person. They ended up receiving medical care and they were okay. But it's a very serious hazard, and it can be lethal to firefighters working in the area. So sometimes those lines are turned off preemptively, even if they are not damaged. So that's something just to be aware of, that you might have the power turned off to your water system as a precaution. They will usually let you know if they have an estimate on when it's going to be turned back on. And then also that arcing can ignite additional fires. So they're just very hazardous to be working under. And if you're in an area that has a lot of above ground power lines, this is something that might impact your water system. In preparation, make sure you're communicating that you're a priority need with your power company. You can get on that critical infrastructure list. Make sure that you are talking about that in your emergency operations plan, what you're going to do if there's a power outage, from all different reasons, right? From a thunderstorm to a public safety power shutoff to a firefighting operation that needs to temporarily shut off the lines, things like that. In response, follow your plan and issue public notices. You are required to alert ADEQ of all power outages, especially lasting 4 or more hours, and follow ADEQ's guidance on starting back up after power is restored, including testing water quality for at least total coliform and E. coli, and providing updates to your public. Make sure that you're maintaining any area around any on-site power lines you might have, especially wooden poles, keeping that defensible space around them. And then consider having a backup power supply of generators, things like that. So keeping all of that in mind, but that is probably one of the bigger or more common impacts from fires, because the wildfire does not have to actually go through the area of the water system for the system to be impacted by a power outage. All right, really, I just like these pictures, but you can have a depletion of your water source from firefighting activities needing water. They don't typically take that much water out of sources, but hey, we've been in drought years and that can certainly happen. Some firefighting activities have helicopters called sky cranes with a snorkel that they will dip down, suck up water, and then drop it. On the right, they call it a Bambi bucket. It's a smaller amount of water, but this could certainly be impacting smaller water systems as well. Sometimes I've even seen them dip out of things like ponds and wildlife tanks and swimming pools. So they can pull out of very small sources. All right, another very big one is the potential for contamination of either your source or your supply. On the left is a plane dropping some fire retardant. On the right, this is a picture of Roosevelt Lake and the dam, and you can see you've got kind of a burned hillside that's a pretty steep slope right above the water source. So kind of your main things are going to be, these firefighting materials like the retardant entering the source, or ash and organic material and burned debris, things like that, rolling down slopes and eroding into your source. And for record, no, you're not supposed to be that close to a plane when it's dropping fire retardant, but we ended up getting a pretty cool picture out of it, and they are used pretty frequently in Arizona now, especially in the desert where fires move very quickly. And there's a lot of areas that are tricky to get to on foot in an ecosystem that is not fire adapted. So it is pretty critical to get the fires out as quickly as possible. And this is sometimes the only way to get it done. So here's some pictures. This is from the Woodbury fire a few years ago. This is out out by Roosevelt, those same pictures from before, but you can see on the right just how effective that retardant line can be. You can see where it's dark, that is where the fire burned, and then you can see, if you look closely, a red line bordering that whole thing. So it was a very effective method at getting this fire to stop in a wilderness area that was very difficult to reach on foot. And then you can see on the left sort of a close-up of some of these areas where you can see spots of ash and burned vegetation, as well as this retardant. So I do want to talk about this real quickly. This is not the same thing they're talking about in the news as the PFAS, firefighting foams, things like that. Fire retardant is sort of the consistency of tomato soup, and it is mostly made up of fertilizers and water. So that can be a concern with nitrogen and phosphorus entering the water system source in higher amounts than it typically would, and leading to things like eutrophication, harmful algal blooms, higher nitrogen levels, higher phosphorus levels, things like that. So just directly impacting the chemistry of the source water. And then ash and burn debris can also cause, increased total organic carbon levels, increased turbidity, things like that. So that's going to be a direct result of additional things washing into the water source. Here's a close-up of what it looks like for that ash and burned debris. You can see here, this is just a pretty steep slope that water will run down, and was previously covered in vegetation that would slow that water down, but now all of that ash is just going to be washed right into the lake and right into that water source. So that's definitely going to change the makeup of the source. Another big potential for contamination is things like VOCs, volatile organic compounds, and SVOCs, super volatile organic compounds, can be created from heating plastic pipes, so PVC and other related materials. Even if they don't burn up or melt, just the superheating of these lines can cause VOCs to form. And then when water goes through these pipes, it will leach into it and pick it up, and it has been found at very hazardous levels before. So that is something to consider too. If you've got a lot of plastic components in your water system, even if your pipes aren't PVC, you might have plastic components to the rest of your infrastructure, and that's certainly something to be looking out for, the potential need to test after a fire has gone through, to make sure that that water still is safe for customers to be drinking. So here's a little slide about a few, just kind of wrapping up what I was mentioning, that you've got heat and PVC or plastics mixing that can cause VOC formation. Things like fire retardants and charred organic matter, coupled with precipitation, runoff and erosion. You could have increased nitrates, potentially harmful algal blooms forming from the additional nutrients in the water. Loss of pressure, power, high turbidity, making the filtration and treatment process less effective. You could have a potential for bacteria contamination. You could have DBP formation from an increased need for disinfectant levels to deal with increased total organic carbon and turbidity, and a less efficient surface water treatment process. And then just increased pressure on your filters in general. There is a lot of organic matter from that runoff, and ash, really small particles, can make it really difficult to effectively filter that water in the way that you would normally expect with the lower turbidity levels and the lower TOC levels. So just especially if you're a surface water plant, be looking at that and have a plan for what you would do in those instances. Make sure you're issuing the right public notices. If you've got a public notice required, seek guidance from IDRC on what type of public notice might be appropriate. For things like E. coli contamination, the standard boil water advisory might be appropriate. For other contaminants where boiling the water might not be helpful, You might want to issue a do not drink water. And then for things like VOCs, boiling the water can actually volatilize those volatile organic compounds. So a do not use order might be most appropriate, where you say that don't shower in it, don't wash your clothes in it. It's only should be used for firefighting and flushing toilets, things like that. So if you have a concern of VOC contamination, definitely get some guidance from ADEQ, because you don't want to be issuing a public notice that could potentially make the water more unsafe for people. All right, so to reiterate, always have these things in consideration in your EOP. Have some extra treatment materials in stock if you can, and then follow all of your plans and issue the correct public notices. Reach out to ADEQ if you have any questions about what you should be using and what type of public notice might be most appropriate. We have templates as well. In recovery, make sure you're testing your water quality. For things like VOC formation, it might be kind of a long, more than one test. You might need to isolate that section that's of concern, test it, flush the water, retest it again. Things like that can leach in for quite a while. And then for mitigation, consider your pipe material, or at least be aware of your pipe material. I know a lot of systems are doing lead service line inventories right now. So take note if you have PVC components, and then maintain that defensible space. The cooler you can keep your plastic components, the less likely you are to have heat impacts from that, as well as just other things that could cause loss of pressure, power, and other contamination concerns. All right, home stretch here. Here's some just kind of a far out picture after the fire, like I mentioned, where vegetation was previously slowing water down on slopes. You're not going to have that anymore. And so your potential for erosion and flooding goes way up for quite a while, especially in areas like the desert, where it takes a while for vegetation to come back without precipitation. And you can see here just really, emphasizing where that water line is going to go on the left, with all that ash and organic material is going to flush right into the lake. So anything that could slow that water down is going to be beneficial. On the right, you see somebody actually installing some monitoring equipment. So if you have, concerns about a fire in your area, you can definitely reach out. The Forest Service or BLM, other federal agencies and some state agencies are probably going to be doing some monitoring work on that, depending on where the fire was. So that's something that might be a long-term impact as well. Here you see a long-term post-fire effect. You can see a tank kind of there in the distance, but this is in a very rural area in a desert ecosystem. So it's not likely to rebound from this fire and its ecological impacts very quickly. So all of this is, changed components, maybe even to the groundwater. So here through, my best advice here would be that flooding might be best treated as a separate emergency. It is a result of a previous wildfire, but it is now an emergency in itself. So make sure that's a part of your EOP. It's site specific. Alert ADEQ, especially if you have any outages, and then test your water quality. Treat it all the same way you would treat any other emergency. But also, make sure that you're maintaining personnel safety. Floods can be very dangerous. You could also have road washouts that keep operators from getting to the site. And so maybe assess your system for flood risk. If the fire were to come through, are components on the ground, are they at risk for flooding? Take a look at that and then build your EOP based on your risk. And then maybe consider some strategic placement of your infrastructure to protect it better. All right, and with that, I mentioned at the beginning of this presentation, I am working on a project to improve communication and planning for emergencies between water systems, drinking water systems in particular, and ADEQ in emergency situations. So please Feel free to email me with any questions, comments, input, or experiences that you might have that could help inform my planning and my work in this area.
Great. Thank you, Bailey. Great presentation. People really love the pictures, and that's key, right? So thank you so much. All right, everybody, we are running a little bit late. I hope you want to hang on. We have one more presentation for you, and you could account for it accordingly on your PDH certificate. So one more presentation for you now. It's we have Ram with NCS Engineering. So Ram, I'm going to turn over the presentation to you. Are you with us, sir?
I was muted. Can you hear me?
There you go. Yeah, I hear you just fine.
All right. Thanks, Jason. Bailey, it's nice talking to you. Welcome, everybody. I know everyone's hungry, but we're holding the food for a few more minutes here. So we're going to talk about reading some as-built drawings. I'm just going to go through drawings and it's going to be a classroom exercise. Okay. So if there's questions, I guess chime in or put them in the chat box, and I'll leave a few minutes as I go through drawing sheets. So I've picked a couple of water projects to get through.
We're not seeing your as-built screen. We're seeing the.
Yeah, I'm going to share it right now.
Okay, great.
Yeah, so I've picked a couple of water projects, well projects. This is the first one. It's a well site upgrade. Is everyone seeing this now?
Yes, we're seeing Amarillo well site upgrades.
Okay, good. It says Amarillo well site. Okay, good. So this is a water system project. It's in near the city of Maricopa in central Arizona. And I'll kind of walk through the as-built drawing and what's on each sheet. And then I've got some more electrical sheets at the end too, so people can kind of know what to look for either in drawings as you're getting them prepared, so you'll know what to review, and then also what's on the drawing so you can make sense out of them. So we'll start with a cover page, and that will be the first one. So normally there's a legal description, the title of the project, who the owner is. In this case, it's Global Water Resources. The title, it says Amarillo well site upgrades, and then you usually have a legal description based on a survey. Okay, much like a property, when you're buying property. So it'll have the southwest quarter of the township range and the quadrant, and so that'll come from the engineer or surveyor as the section number and basically a legal description, and then you'll have a date. Okay, if it's a design versus a record drawing, there's a standard as-built certification, and this is something for a record drawing. ADQ requires it. We put it on when we're generating an as-built versus a design, and it has that date on the cover, which is the date of the drawing. Okay. One thing that you'll see as I go through this, with CAD technology changing, some people do them differently. They won't indicate the changes in the field, but I think it's a good idea for everyone to know what was changed. Okay, you could generate an as-built and you're just marking it as a final record drawing, but you don't know what was changed from the design. So I still like to do it the old-fashioned way. When we started doing this, it was on bond paper and vellum and mylars almost 40 years ago, and so before CAD. So you'd actually physically make the changes on a sheet on an as-built. And you'd indicate what those changes were. So it's still good to do that. There's places on a title block when you go up here, you'll see revisions, and it has revision 1, revision 2, the date of those revisions, and the as-built. So there's a record of what the as-built is. Okay, so it's always good to have revision dates. So if you're getting revision dates through construction, you may have one that's a final design set, ADQ approved it. There may be some revisions through design and bidding. Those revisions could be made, and then you have a final one during construction. So I think it's good to document those changes so people know what they're looking at. The next thing you'll usually see on the cover sheet will be the sheet index. So we'd have the cover sheet, civil sheets, and then mechanical sheets, and then electrical sheets also if you have those. So those are here. And then again with CAD, you know, what we have is these are indexed. There's a sheet set manager that automatically, you know, links your sheets and can renumber them, re-reference the details. It's one of the tools in SCADs that we use to save time and money. And so the index is a big part of that. The next thing you look for on the cover sheet is the location map. Okay, you have the legal description, which corresponds to the location map, which is in general. Okay, here I'm on I-10 or I'm on 8. I'm in Chandler, Gilbert, Phoenix. How do I get to this place? It's out in the middle of nowhere. That's what the location map shows. And then we typically will show something closer scale. When you get close, okay, now I'm down here. And then how do I find it? And here I'm going down 347 to the location. So you try to provide enough guidance for ADQ, bidders, subcontractors, inspectors to find the site. So that is a cover sheet. Okay, the next sheet, you know, it will be a general sheet, which has general notes, symbols. These are all the civil and mechanical symbols. So you'll see different things on here that reference, you know, symbols that are shown that, so you don't call them out each time, from contour lines, gravel or surfacing, and they go with these kind of cartoon-like symbols, a tree, a bush. So these typically aren't labeled again. You'll rely on the symbols. I mean, there's neat things here. There's like a Palo Verde line, an Ocotillo. We're going a little crazy here. There's different types of trees that are available, gates and symbols. So these are used on the drawings, so you don't have to keep relabeling everything. Okay, so there's a civil legend, then there'll be a mechanical legend also that corresponds, and then abbreviations. You know what various abbreviations are. That'll be shown also. You know, top of slab, TOS, top of curb, TOC, top of bank, pavement, PE, natural ground. So you'll have all that on the second sheet usually, along with some general notes on the smaller projects. Here you see a revision for the as-built. And this revision, let me try to close this. Oh, hold on. I don't want to leave the seminar. Let me try to move this here. Okay. Excuse me 1 second. This is kind of getting in the way. So you'll see this is what I was calling it. When you do an as-built, you'll have a revision bubble. Okay, and marks the date 1, and that corresponds to the one that you'll see on the right side here with the revision block. Okay. I'm gonna try to move this around. So here's the revision 1. It puts the date. Okay. That way you can see that was done as part of the as-built process. And this is the ADQ notes. Typically there you'll see requirements for disinfection, bulletin 10. Here there's NSF 60 and 61. Those will generally go on water projects. We meet all the ADQ criteria that the project was done based according to the pressure testing, the leak testing. Okay, so if you're making submissions to ADQ, you want to make sure these notes are mandatory to get approval from the design group and to get your approval of construction. The benchmark is good. What are you indexing the survey to? There's so much bad surveying out there, guys, that you want to get a good benchmark and you want to show that. So you know what your horizontal and vertical control is referenced to. And this is usually, in this case, it was a Pinal County datum, a benchmark from their Department of Transportation. And then all the references are taken off of that. Then we'll have general construction notes and site notes, okay, for the source of the survey. And then, you know, general construction notes for clearances between pipes, how much cover, and those type of things. Okay. Next, we'll get into a little bit, the next thing you'll normally see is a demolition plan on a set of drawings. Okay, and here you have a demolition plan for the overall site demolition. Okay, so in this case, we'll kind of walk through it. We were replacing the wall, so you have these are the demo notes to replace the wall, so that's documented. And then we're installing new panels, so we're demoing the electrical panels, asking for that work to be shown. Okay, electrical, There was a shed here for water quality. That shed was returned to the owner. More demo of the CMU block, and then removing some concrete. The reason this concrete was removed so that when the new wall was taller, so we needed the footing, enough length for the footing underneath there. So this will be your site demolition plan. Okay. Then you'll go into your new site facilities, and that's usually shown on a civil drawing. And so here's where typically you'll show in plan view the wall. Here's your new wall shown. TOW is the top of wall elevation. TOF is top of footing. And then you'll see a cross section here. When you read the map, you know, what does that wall look like? So typically you'll call the elevations on the new civil site sheet, top of wall, top of footing. Every time there's a grade break, okay, the wall changes elevation or the footing changes, that's what's shown on here. So you can see here, we have a top of wall 1229, top of footing 1218. So it's a pretty tall wall. And then we're crossing across some drainage here. So now it drops lower. So we have a 1217, it's dropping about a foot, okay, at the footing. And then we have a different section called out here through. So on a plan view of a drawing like this, you'll see the top elevation, and then the sections will be used to call out the details. Okay, so you have more wall cross sections. So it's quite a big wall. This is a couple $100,000 of wall. And you can see elevations are called throughout the site elevations. There's also grade elevations. Right here, you'll see a grade contour line, this 1220. And that's so you're setting the grade so the water flows to the retention basin. Okay, so your civil site will show work generally like grading, your new concrete pads, and you know, the non-mechanical elements that a project has. Okay, and then here are some of the wall details that we're talking about. As you go into the wall details and sections, you'll see the rebar on drawings, whether a masonry block is grouted or not. Okay, you know, and then the rebar that's needed in the masonry block. When a wall gets taller, like this one we have here, you can see it's 8 foot tall. On a 6 foot, you don't need to grout it. But on an 8 foot wall, here's where we have the footing, and you have a taller wall. And then you'll see that we have number 5 rebar 24 inches, and that's grouted. Okay. And then it's grouted all the way down at 24 inches. Okay. And then you have the finished grade. And so they can build the wall off of this, and then the horizontal will be on the prior sheets. And same with the gate. We have the gate detail here, the wall with redwood slats on the gate, typically show the grade so people know how tall a gate is and how tall the wall is. Okay, so these are all the sections that are called from the previous sheet. So this typically you'll say section A, it's from sheet 03 on sheet CO4. Okay, so all the sections, the several that we saw on the prior sheet, they're referenced, and that tells you to go to the next sheet, which is CO4. So those are called section cuts. Okay. And then here again, you'll see there's also a record drawing. When you see an as-built or a record drawing, we like to put this stamp on it. And you know, we don't throw that stamp around. We usually will verify it to make sure that we're confident. A lot of times we'll get as-builts from somebody else that do not look like what's out there. Okay, so really by PE standards and the board, you're not supposed to put the stamp unless you've gone and verified it. Okay, so we generally will not do a record drawing unless we have verified that drawing by going out in the field and checking it to the best of our ability. And that's what we're saying here. So sometimes we get these as-builts that make no sense, and you know, that's why someone probably didn't go out there and verify. Here is the wall with the drainage. There's a little bit drainage one of the sections. It goes underneath, and there's drainage knockouts, and that's what's shown there. And then now I'll move into some of the more juicy water, wastewater mechanical. We'll start with a schematic. Okay, that'll be on the first mechanical sheet. So in this case, we have a chlorination system, you know, a well, and this is basically a line diagram. was showing all the instruments. So we have a well, air release valve, pressure switch, pressure indicator, check valve. We have a pump to waste control. Okay, so our gate valve for isolation, and then this is like a clay valve. So, you know, we can waste or we can go to the system. So basically starts up where the system valve is closed, the waste valve is open, and after a few minutes of the pump out, this valve closes and it opens to the system. These are solenoid type control valves. From there, we have a sand separator, okay, desander with a waistline, solenoid valve, waistline, flow meter, and then it goes to the distribution system storage tank, okay. Likewise, we have a chlorination schematic with a chlorine storage tank, a double containment FRP tank, poly tank, I'm sorry, with metering pumps that then go through and feed the system. Okay, so the schematic kind of shows you mechanically what you're going to see. So as an operator, you should be able to follow the schematic. If not, then register for another course with Cal, okay? Or you can call me or Jason. And that's important, okay? From that schematic, and I'll wrap up here, I know we're a little over here, we go into the mechanical sheet. This is another one that looks a little intimidating at first, but really if you understand the schematic, then you can follow what's happening with the plan drawings. And here again with CAD and the sheet set manager, what you have is you have notes that are numbered, okay? And because of the automation, it makes changes quickly. So you'll have a number 10, and that looks like it's pointing to an elbow, and then that's what it is. It's a 10-inch, 90-degree elbow. So these are what we call keyed construction notes. They'll be on the right side. So it describes every element of the drawing. And so there's about 27. Oh, there's more. There's 32. And these describe what you're seeing and what the contractor would build here. Okay, so if we look at these keyed notes, and it makes it simple to make changes. So if we follow it, we go from the wellhead, those are the keyed notes, air release valve, check valve, then we go through the desander, okay? The desander is here, the pump to waste valve is here, okay? And then it comes back from the desander through another isolation valve, and then we have our pump control valve that's on this side. Okay, so normal flow, it goes up through here. This valve is closed. So this is used when you take the desander out of service for maintenance. You'll bypass it. Goes through here, comes on in through the pump control valve, flow meter, coupling, and then distribution system. Next to it is the chlorine storage tank, and all the mechanical. If you correlate it to the schematic, all this will match the schematic. Okay, so for everything that's on the schematic, you'll see an item here that'll be on the mechanical plan sheet. Okay, and here again, it looks like they changed something. They changed here. You'll see the bubble and the revision during the as-built. So this section they changed. So if you're comparing the two drawings, you'll see that they probably changed the fitting or dimension here, you know, right at the wellhead. So you look for those clouds, we call them clouds, and the revision blocks is how they do that. So then there'll be sections, usually from the plan view here, there'll be sections that are cut, okay? And then those sections, this one first section here is, we'll go through them, and that gives you the perspective view looking at. So here's section A from sheet M01 to sheet M01. So if I go to the drawing above it, I should see a section A here. And then, so here's C, and here is B. So you have B, C, and then here is A right here. So A is the big well header. That's right here. That's below it. And then B and C go to the next sheets. So that's that same pipe, the well header, but it's shown in an elevation view. So you can see, okay, you know, how far is it off the ground? Here's my pipe supports. Here's what it looks like when you're standing there. Okay, so we always cut sections to go through that. And here's section B. So you see the pipe coming in, the pump control valve, and then this is the waste pump control valve and the isolation. And then here's the section next to the descender. Okay, so it gives you different perspectives as you walk through the plan view. Okay. The next one is the chlorine tank, and you'll see again there's a plan view that shows the tank, the eye wash. You have a fill station here, 2-inch line to fill the tank. Okay, then we come off the level transmitter, so everything is kind of called out here, access ladder. And then that comes off to feed the metering pump. And then again, similarly, there's a section cut off of here. You see the section that's right here off of the tank. Okay. And then last here is the sodium hypochlorite pump. You'll see the 2 pumps here, metering pumps with the tubing. You have isolation ball valves, and then it goes to the chemical injection point. And so you'll see a lot of this is done with notes, and you'll see things are numbered. So you'll see, 4 are the metering pumps, and it has the model number. Okay, 8 and 9. 8 or 9 is the back pressure valve and the drain to the discharge pump. Okay, 1/8-inch ball valve, the tubing, flexible tubing, and then the rest of this is hard pipes. So when we use the notes versus it makes the drawing less cluttered and it's easier to make changes. So, and then last, Jason, I'm going to close with this for now because I'm at the half an hour. I think we need to do a separate one on electrical drawings. There's just not enough time to cover electrical instrumentation. I can give another one at the next one for that.
Yeah,
and then typically you have mechanical standard details like the eye wash, pipe supports. This one's a pressure gauge for the high pressure switch. Okay, and these are just standard details that they're referred to this sheet from the main drawings. Okay. All right, so with that, Jason, I'll close for today, and then I don't have time for the electrical instrumentation. That'll probably take another half an hour by itself to an hour. Okay.
Great. Thank you, Rob.
I can take any questions now, or turn it back over to you.
Yeah, I'll take it over now. I've been answering some questions as they came up. So let me just take over one more time.
Sure.
And just wrap it up.
How do I turn it back over to you?
I can take it.
Can you take it? Okay.
Yeah. All right. Well, that wraps up our presentation, everybody. On my screen, you should see all the contact information for the presenters today. If you want to go ahead and take a screenshot of that, that's okay. You can do that. This will be available afterwards. And all the presenters' information is also available on the agenda, which is also your PDH form. So I want to thank everybody for attending today. I hope it was worth your time, and have a great day.